matrices and determinant. So hope every one of you are ready with this. Okay, so let's wait for 5 to 6 minutes for everyone to just connect. So happy new year everyone. But study is always there, so we should be studying, isn't it? In a short while, we are going to start with matrices determinant one shot, where we will be covering everything from basic to advanced, everything. Okay, so hold your sheet. We'll begin with this. Okay, okay. We are still waiting for 1 minute. Then we'll proceed, isn't it? It's algebra of matrices. First, we'll start with the introduction, and then we'll proceed ahead. I think we are done with this everything. So let's continue. Introduction of matrices. So in this introduction, what will happen? There used to be an era, okay? So there used to be an era where there used to be like this. Like there will be some name and there used to be marks. Physics marks, chemistry marks, maths marks. So like one name 50, 60, 70. If you have some second name, you will have 40, 50, 30. So this is the way the data used to be. And what used to happen is that storing data in this way, storing data in this way used to be like very difficult, difficult to handle, not able to handle anything. Like if you wanted to handle for any mathematical calculation or whatever, it used to be a bit difficult to handle. So okay, so in order to do that, we came out with something that was matrices. Okay, from here we came out with matrices. So from here what happened, we came out with that we'll write something x and we'll write something maybe if it is 40, 50, 60, 70, 80, 90 and 30, 40, 50. We'll consider this is the marks, this is the marks, this is the marks for different subject, and this is the name of the people. Okay, so this is what we considered. Okay, so from there the origination of matrices came out. Now, now what will happen? I'm trying to say that uh, if if you're looking this has 3 row, so we'll write it as 3, and how many column it has? 3 column, so we'll write 3. And we can say that order of the matrix is 3 into 3. So this is representing row and this is representing column. This is row, this is column. Okay, this is row. So in general form, what will happen? We'll write capital A equal to AI first row, first column, A11, A12, A13, dot dot dot, A1J, dot dot dot, A1N. Okay. Similarly, this will come out to be A21, A22, A23, dot dot dot, A2J, dot dot dot, A2N. Similarly, we'll go dot dot dot, A M row 1 column, M row 2 column, dot dot dot, 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 and here dot 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 dot, A M row N column. So we can see it is M row N column, and Aij meaning ith row jth column. Okay, so this is what it is represented. Okay, and we can simply denote it as, if you talk about denoter, we can say A equal to AI AI J M cross N. Even if you write only this much, it means it is whole determinant, whole matrices. This is what it is trying to say. Now let's move ahead. So Aij meaning what? Ith row jth column. Okay. Diagonal element. So diagonal elements across diagonal. So if you go there, you will find that this is a diagonal matrix. This is a diagonal element. Okay. These are diagonal element. So we can note it like this. Diagonal elements. Okay. Trace of a matrix. Trace of a matrix is sum of all the elements of diagonals, sum of all elements of the diagonals is called diagonal matrices. It's called trace of a matrix. Matrix is denoted by, so we already studied A equal to small a I j m cross n. That means ij is spread like m cross n. And order of a matrix is denoted by m into n. That means m row and column. Okay. Now construct a 3 into 2 matrix whose elements are given by aij equal to 1 by 2 I minus 3j mod. So we'll write a, we'll have something 3 row 2 column. Yes, 3 row 2 column. So this much is enough. 1 row 2 row 3 row. Column is what? 1 column 2 column. Okay. So if we go with, here we'll have first row first column, first row second column, second row first column, second row second column, third row first column, third row second column. Okay. Okay. Third row first column, third row second column. So now based on that, if we write a11, it is what? 1 by 2 mod of 1 minus 3, which is 1. A12, it is what? 1 by 2 1 minus 3 into 6, which is 5 by 2. A21, 1 by 2 I is 2, j is 1, which is 1 by 2. A22, which is 1 by 2 2 minus 3 into 2 6, which is 2. A31, 1 by 2 3 minus 3, which is equal to 0. A32, 1 by 2 I is 3, j is 2, which is 3 by 2. So if you see, A will come out to be 1, 5 by 2, 1 by 2, 2, 0, 3 by 2. Okay. So this is the new constructed matrix. Okay. Okay. So we are going with now row matrices and everything. Different types of matrices, isn't it? It's simply type of matrices. So row matrices, a matrix having only one row, a matrix having only one row is called row matrices. Okay. So we can say that its order will be 1 into n, so one row n column, okay, and its example will be somewhere a equal to a11, a12, dot 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 a1n, okay. So this is row matrices, and this is important, okay. Okay. So determinant and matrices has more weightage. You will get around 3 to 4 question in mains and 1 to 2 question in advance. Okay. So we have website. So we have website like Ankit Kumar. So ankitkumar.com, godedit Okay, if you go this website, we have everything there. Okay, we have online things. So this is a row matrix. Now we'll proceed ahead. Now it's time for column matrix. So for column matrix, wait a second. Hello. मैसेज आया नहीं ऐसे नहीं है स्क्रीन पे अच्छा न्यू ईयर वाला ना हाँ न्यू ईयर तो आया पैसा ही नहीं आया ये पैसा ही मांगा आपको किया ना से हाँ आपने देखिए आपको क्या आपको चलो जा रहा है तो दोस्तों फोन करेंगे मैसेज करेंगे तो काम शिफ्ट करना फिर आप पैसा नहीं देंगे So column matrix. So you answer me, how would column matrix work? So column matrix is a matrix having just one column and multiple rows. Okay, so this is called column matrix. Okay, so if you see, it is denoted by capital A equal to Aij. So n row, one column. If you see it further, it is somewhere like this: A, one row, one column; A, two row, one column; A, n row, one column. So this is n row, one column. So this is the way it is done. Okay, denoted by capital A, and what more? Nothing more. Okay. example in order. Okay, now we are going to zero matrices. A matrix is said to be zero matrix if all elements if all elements of the matrices are zero. That means we can say that Aij Aij is equal to 0, or we can say example capital A equal to 0 0 or 0 0 0 0 or 0 0 0 0 0 0 or 0 0 0 0 0 0 0 0 0. Okay, so this is the way it goes. That's a zero matrix. Okay, for all ij. Okay, we move ahead. So we are on a square matrix. So square matrix meaning what? M equal to n. Can we say square matrix M equal to n? A matrix is no. A matrices whose numbers of rows is equal to numbers of column. Okay, that means what? Capital A is represented at A Ij n cross n. Yes, or Aij m cross n, where m is equal to n. So this is what it is simply. Okay, so this is it. Example, A11 A12 A13 dot 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 A1n. Similarly we'll go dot 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 an1 dot an2 dot ann. So you will see that it has n row n column. So this is the best example. Let's move ahead. Scalar matrices. That means identity matrix multiplied with some constant, I think. Okay, scalar matrices is something identity matrices multiply with some constant, I think. So before that, I will we have no identity unit matrices. Okay, see, scalar matrices is what? A unit matrix multiplied with some constant. So if a unit unit matrix is 1 1 1 0 0 0 0 0 0. So diagonal element as 1. Now we are multiplying this unit matrix A with lambda, which will become lambda 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 0 0 0 0 0 0. Okay, and we can consider that this is B. So this is scalar matrix. This is scalar matrix. So B is scalar matrices. And one more thing, if you want to observe diagonal elements are same. Okay, diagonal elements are same. Got it? Or we can say that if you want to see mathematical Aij, Aij is equal to 0 if I is not equal to j. Okay, and Aij is equal to k or lambda for all I equal to j. So that we can observe simply, isn't it? Moving ahead, diagonal matrices. So diagonal matrices is a matrices having element present in only diagonals. Okay, so diagonal matrices is a matrix with at least one element non zero in its diagonal. Okay, and rest of all non diagonal elements are equal to 0. That means if you see this diagonal matrix A, it has diagonal element A, B, C, all elements are 0. Okay, This is what 3 cross 3, the order. So we can simply say that Aij equal to 0 if I is not equal to j. Okay, and then at least one element should not be 0 for I equal to j in Aij. Okay, so this is the diagonal matrices. Let's move ahead. So unit matrix is also called as identity matrix. So we are now expert in the thing. We can say Aij equal to 0 if I not equal to j, and Aij equal to 1 if I equal to j. That means every element in diagonal hello, happy new year everyone. Okay, every element in diagonal should be equal to 1. Okay, rest all element other than diagonal should be 0. Okay, so if you take example, and this type of matrix, this types of matrix is always a square matrix. Okay, this type of matrix is always a square matrix. Got it? Now if you consider A, it should be square, so 1 0 0 1. It should be square 1 1 1 0 0 0 0 0 0. Go with 4 1 1 1 1 0 0 0 0 0 0 0 0 0 0 0 0. This is 4 cross 4. This is 3 cross 3. This is 2 cross 2. Okay, so you can find that it is possible only when it is a square matrix. Okay, so I think in diagonal matrix also it should be a square matrix. Okay, so we can say that it should be a square matrix. Okay, upper triangular matrix.
आपको मैसेज किया
कॉलम को कर दिया हम भेजिए भेजिए okay. So triangular matrix. So I am giving you all one challenge that you tell me what is upper triangular matrix. Okay. So this is your task. So this is your task. What is upper triangular matrix? I am giving you 1 minute of time to think. Kindly think and then tell me. So this is a basic concept, okay? If you are trying to know, this is just a basic concept, upper triangular matrix. So in this, what will happen? If you try to know mathematically, uh, if I is bigger than equal to j, if I is row, second row, first column, second row. So what will happen at upper triangular matrix is what? If this is a matrix A, B, C, this is 0, 0, 0. This is upper triangular matrix means having element only on upper side. So maybe E, 0, F. So there is element at least. Yes, all the elements are not 0 on this side. So this is what? First row, second column, first row, third column. So this is second row, first column, second row, second column, third row, second column. So this is 3 into 3. So from this can we say that Aij is not necessarily 0, not necessarily 0 for all I. I bigger than I is j bigger than equal to I. Okay, and Aij is equal to 0 for all I bigger than j. Is it correct? For I bigger than j, it is 0. So this is the correct, okay? So if you see that we can describe this only by saying ij. We cannot have any simpler definition, okay? So what will happen now? If I write note, minimum number of minimum numbers of zeros possible in upper triangular matrix, okay? So what will happen, if you see this is 3 row 3 column, we are adding 1 2 3. So n n plus 1 by 2 is the minimum of non-zero. Okay, but here if you see it is 1 2, if it is 3, it is starting from 1 2, that means it is going from 1 2 3 up to n minus 1. So it will come out to be n minus 1 by 2. Okay, so what will happen, if it is 3 then we have only 2, if it is 4 we'll have up to 3. So it is n minus 1 by 2. And maximum number of zeros, if you go with maximum number of zeros, then I think all are zero, like n square. Okay, now lower triangular matrix, just the reverse of upper triangular, but diagonal elements are also not zero. So we'll say here that aij is equal to 0 for I. So upper side will be 0. Okay, that means first row second column, I less than j. Can we say this? Yes, I less than 0, aij is equal to 0. And the minimum number of zeros are same because diagonal elements are there. So it is going to be n minus 1 by 2. So this will come out to be a. So lower triangular will have a, b, c, d, 0, f, maybe g we can keep, but this not be necessarily 0. And this is 0, 0, 0. Okay, so this is lower triangular. Comparable matrices. Okay, if we are solving some matrix, so comparable matrices meaning if we are given two matrices A and B, okay, then what will happen? Then the order of A and B should be the same if they are comparable. Okay, so if two matrices are given and we are told that they are comparable, that means their order should be same. Okay, now what will happen, we'll give you some example. If you understand this order thing, then I think you are not going to face any problem. If this is 1 2 3 4 5 6, this is 2 row 3 column, and if you are giving 2 3 4 5, this is 2 row 2 column. If you say these two are not comparable, okay, Second example, 1 2 3 4 and 2 3 4 5. They're what? 2 into 2, 2 into 2. They are comparable. Okay. So I think this went into your mind very nicely. Now we have singular matrices. So singular meaning matrices. So matrices, and the matrices are going to be only square type, square matrices. Matrices, square matrices whose determinant is equal to 0. Okay, that means determinant of A, also known as determinant of A, should be equal to 0. Okay, if I take some simple example of a matrix like 1 1 minus 1 minus 1, if you try to find determinant of A, which is determinant of 1 minus 1 minus 1 1, if you solve it, it is 1 minus 1 0. Then this is singular. This is singular matrix. Okay, got it. Let's move ahead. Non-singular matrices. Determinant of A not equal to 0, and it is also a square matrices whose determinant are not equal to 0. Horizontal matrices. Okay, now we are on horizontal matrices and vertical matrices. So horizontal matrices, the matrices in which number of column is more than number of rows. The matrices in which numbers of columns is more than numbers of rows. That means if order is m cross n, that means m is number of row, m is less than n. Okay, so sir, please example. Example is 1, 2, 3. Example is 1, 2, 3, 4, 5, 6. So this is what? 2 row, 3 column. This is 1 row, 3 column. So simply you can get all the examples, isn't it? Let's move ahead. Vertical matrices. So we'll simply say row is in this vertical, so it means column row should be more than m, should be more than n. So numbers of rows should be more than numbers of columns, that is m is bigger than n. If order is m cross n. Okay, now these are the topic which are coming now. Idempotent matrices, these are the topic which are more useful for JEE mains purpose. Okay, so what will happen? JEE mains would ask such type of question. They will not give you definition, and if such type of things comes in JEE advanced, they will put you as a paragraph. Okay, so idempotent matrix is a square matrix is idempotent provided a to the power n is equal to n. It is equal to a. Okay, a matrix is said to be idempotent if a to the power n equal to a, where n is bigger than equal to 2. Okay, and note a is a square matrix. Got it? And a to the power n is equal to a. N is bigger than equal to 2. This is the definition you will have to remember. And A is a square matrix. That's all. Nilpotent matrix. I think A to the power n equal to 0. Okay. So nilpotent matrix. A matrix, a matrix, a square matrix which is which is going through some, which is a to the power p equal to O given given a to the power p minus 1 was not equal to 0. Okay, got it? That means what will happen? P will have to be bigger than equal to 0. P will have to be bigger than equal to 3, I think, because if P is 1, P is 2. Okay, so P is bigger than equal to 2, such that the first A will itself not be 0. So this is nilpotent. Got it? Let's move on. Periodic function. We are told that periodic function is ax plus t equal to a. So what will happen if a square matrix if a square matrix follows a t plus x, a to the power t plus x equal to a to the power x, then if it follows this way, then t is period of matrix. That's all. Okay, or what can we say simply? We can say a to the power t plus 1 is equal to a to the power 1. This could be simply spoken, isn't it? So this is periodic matrix. Okay, now involuntary matrix. So a square matrix following follows a square equal to I. A square equal to I. So this is simple to remember. A square equal to I. Or you can say that A equal to A inverse. Or if you want to say it, you can say it simply taking inverse both the side. So A equal to A inverse. This will come in later topic. Okay. But for now you can consider A square equal to I. This is called involuntary matrix. Okay. Now next what? Orthogonal matrix. So orthogonal matrix is somewhere A transpose A equal to I. So I will give you some small example, like if A is 1 2 3 4, A transpose will be 1 2 3 4. So I am just telling you that A transpose, in A transpose we are exchanging rows with the column. We are exchanging row with the column. So this row got exchanged with the column. So column came this way, row came this way. Okay. So this is the way it goes. Moving ahead, equality of a matrix. Equality of matrix. If two comparable matrices are given as A and B. So A is somewhere x plus y 2, x minus 1 4, and B should be comparable, that means 2 row 2 column. So this is told as minus y x, and this is 1, and this is 4. So what will happen? A and B are given, A and B two comparable matrices are given. If in question we are told that A equal to B, so what will happen? Then we can simply solve the corresponding elements by equating each other, by equating each other. So what will happen if it is given A equal to B? We'll simply compare it. We'll say x plus y equal to minus y, x equal to 2, x minus 1 equal to 1, this element, and 4 is equal to 4. So can we say that x equal to 2 again? And now when x is 2, y is minus 1. This. So this is the comparable matrix. We have equated the element of both the matrices. Now this is what it is. Okay. So I want you all to solve this one. If you could not solve this one, I will solve this one. Okay. So this is comparable matrix. Let's solve it. So A and B are equal, okay? So if A and B are equal, we'll simply compare the element sine theta equal to 1 by root 2. This also cos theta equal to minus 1 by root 2. Okay. Tan theta equal to minus 1. If you see, this thing, you'll find that cos theta is negative on this side, tan theta is negative on this side, but sin theta is positive on this side. So by looking this, can we say it is pi by 4, theta equal to pi minus pi by 4, which is 3 pi by 4. So the answer is 3 pi by 4. Simple trigonometry. If you have any doubt, you can comment me. Otherwise, we are moving ahead. In this, it is again a comparable matrix. So we have to check the equality of matrices. So what will happen? We'll do x plus 3 equal to 0, which is x equal to minus 3, z plus 4 equal to 6, z equal to 2, 2y minus 7 equal to 3y minus 2. We can say y equal to minus 5. A minus 1 equal to minus 3. A equal to minus 2. 2c plus 2 equal to 0. C equal to minus 1. B minus 3 equal to 2b plus 4. So B equal to minus 7. So we got all the answers. So this is the way, if you know the equality of the matrices, we can solve any question very simpler. The question was appearing really difficult, but while solving, we could solve it easily. Okay. Now we have few questions. Minimum number of zeros in upper triangular and lower triangular. We already gone through this, which is n minus 1 by 2. Okay. Minimum number of ciphers or zeros in the diagonal scalar or unit. So minimum number of zeros, what will happen? It is n minus 1. What will happen in diagonal matrices? If all the elements are occupied, okay, so total zeros when all the elements are occupied. So all elements are occupied are n, like total number of element is n square minus diagonal element is n. Can we say it is n into n minus 1, which is written here. Maximum number of ciphers in above. So in diagonal matrix, what can happen? At least one element is not 0 and all are 0. That means n square is total number and one element is not 0. So that's all. Now we'll come to properties of addition, multiplication of matrix by scalar. Like this will come here, okay? So properties of addition. So first, while studying properties of addition, we'll see what is addition first. Okay, then only we can move to addition. Yes, properties. So in addition or subtraction of matrices, we perform operation in between corresponding corresponding rows and columns element. So corresponding rows and column element. For example, if it is 1, 2, 3, 4, this is 3, 1, 4, 5. Corresponding row. So for this one, it is one row, one column. So we should be looking only at one row, one column, and then we will add it. That means it is what? 1 plus 3, 2 plus 1, 3 plus 4, 4 plus 5, which is what? 4, 3, 7, 9. If we have to subtract 1, 2, 3, 4 minus 3, 4, 1, 5, which is 1 minus 3, 2 minus 1, 3 minus 4, 4 minus 5, which is what? 1 minus 3 minus 2, 2 minus 1, 1, 3 minus 4 minus 1, 4 minus 1 minus 1. So this is the way we perform it. Okay, now, okay, it is still in properties of addition. Okay, 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 okay. So it was property. Okay, we got this one. Now we are moving to here. Here we will write properties of addition. Okay, so we'll solve this question, and we should note one thing here. Okay, one thing we should note here is that both or all the matrices, those are used for addition or subtraction should be comparable matrices. Okay, now we'll solve this question. So solve this. So I'm telling you one thing, if we multiply 2 into a, so we studied in scalar matrix that if we multiply 2 into a, we are going to multiply 2 to every element, which is 16, 0, 8, minus 4, 6, 12. If we are going to multiply 5 to b, it is 10, minus 10, 20, 10, minus 25, 5. Now if you see, it is 2a plus 3x equal to 5b. You can simply say that 3x is equal to 5b minus 2a. If you simply say 5b is what? 10, minus 10, 20, 10, minus 25, 5, minus 2a is what? 16, 8, 6, 0, minus 4, 12. It is 10 minus 16, minus 6, minus 10 minus 0, minus 10, 20 minus 8, 12, 10 minus of minus 4, 14, minus 25, minus 6, minus 31, 5 minus 12, minus 7. So now we got 3x equal to minus 6, 12, minus 31, minus 10, 14, minus 7. So if we multiply 3 to all number, 3 is multiply. If we divide 3 to all number, it will be divided to every number. So it is minus 6 by 3, minus 10 by 3, 12 by 3, 14 by 3, minus 31 by 3, minus 7 by 3. So this is the answer. Got it? I think this concept will help you very much to solve this type of question. Now we are moving to properties of addition. Okay. So properties of addition, it is simple, not much. It should be comparable, we know. A and B should be comparable. Okay. Second, A plus B is equal to B plus A. I think this is symmetrical form, isn't it? 3. A plus B plus C is equal to A plus B plus C. Fourth one, if we add A plus O, we can say O plus A is also the same. Fourth, A plus minus A is equal to O. Okay. So we can say from here that additive inverse of A is minus A. Sixth one, lambda constant A plus B is equal to lambda A plus lambda B. Seventh, lambda A is A into lambda also. Lambda is a constant. Lambda is a constant. Okay. Seventh, 8. Lambda 1 plus lambda 2 into A is equal to lambda 1 A plus lambda 2 A. Lambda 1, lambda 2 are constant. Okay. This is it. So properties of addition done. Okay. So scalar multiplication meaning if A is A1, A2, A3, A4, lambda A will come out to be lambda A1, lambda A2, lambda A3, lambda A4 in scalar multiplication. We multiply scalar to every elements of a matrix. So now we are on multiplication of matrix. Okay, so for this, before this, I am giving you 1 minute of just simple break. Okay, okay, okay. So multiplication of matrix, we'll start that. Okay. So in multiplication of matrices, when we'll perform this thing, okay, what will happen if we are given two matrices A? It is A1, A2, dot 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 AN. This is A1N, 2N, ANN, okay, or AMN. And if you go here, M row N column. No, it is 1 1 1 1 1 N, okay. I'm just trying to keep it simpler. This is A1 and A A11, A12, A1n. This is AM1, AMN. Okay, so this is M row n column. If it is B should be in such a way that it should match and we should match the column of A. Then it should be n into L. So 4 multiplication multiplication of A B, the column of A should match the row of B. So we can say that AB is not equal to BA. Okay. And now we'll take one simple question and we'll see how the multiplication works. Okay. So if a matrix is A1, A2, A3, B1, B2, B3. This is what? 2 row, 3 column. Then B should be something 3. That means 3 row is simply okay. So A, B, C. So 3 row is there and we can keep only one column for now. Okay. So A, B will come out to be A1, A2, A3, B1, B2, B3, and this will come out to be A, B, C. If you want to keep it 2, for example, we are keeping, it will be, let's example A1, B1, C1. So A1, B1, C1. So this is 2 row, 3 column. This is 3 row, 2 column. So the resultant will come out to be 2 row, 2 column. Okay. So this will be what? We'll multiply first element of this one with this one. A1A, put plus, multiply second element. Hello? Yes, yes. Okay. Okay. So this is A1 multiplied with A plus A2 multiplied with B plus A3 multiplied with C. Okay. Similarly, we'll multiply A1 with A1 plus A2 with B1 plus A3 with C1. Similarly, B1 with A plus B2 with B plus B3 with C. B1 with A1 plus B2 with B1 plus B3 with C1. So if you see, the resultant has come out to be 2 cross 2. Okay. So this is the way we should be proceeding. So multiplication of matrices, this will take few questions. So this is the question. I am giving you 1 minute of time to solve it. Then I will solve you. So try this one, everyone. I am giving you 1 minute of time. So I think you got 1 minute. Now I am trying to solve this question. So ABC, which of the following products are defined? So what will happen? A is 3 row into 3 column. B is 3 row into 2 column. C is 1 row 3 column. So if you see, AB is feasible, but BC multiplication is not feasible. So ABC is not feasible. ACB, ABC is not feasible. If we go with ACB, so this is feasible, but this is not feasible. BAC, BAC, not feasible, not feasible. BC, A, this is feasible, this is not feasible. C, AB, so C is this, A is this, B is this. So this is feasible. So this is feasible. CBA, CB, A, this is feasible, this is not feasible. So only one of them is feasible. So now we have to calculate the product of CAB. So we have to calculate the product of CAB. So let's calculate. C is 3, 1, 2. This is small, okay. B, CA, A is what? 4, 3, 1, 6, 0, minus 2, minus 1, 2, 5. And B is what? 2, 0, minus 1, 4, 1, 2. We'll multiply this row with this column. Simply getting, this is what? 1 row, 3 column, and this is 3 row, 3 column. So outcome will be 1 row, 3 column only, okay? So 3 into 4, 12. 1 plus 3, 3. So 12 plus 3, 15. 15 plus 2, 17. 18 minus 4, 14. Minus 3 plus 2. Minus 1. Minus 1 plus 10, 9. And we are here with 2, 0, minus 1, 4, 1, 2. So this is 1 row, 3 column. This is 3 row, 2 column. So outcome is what? 1 row, 2 column. 17 to the 34. 34 minus 9, 25. 17 4 the 68. 68 plus 14. 82. 82 plus 18. 100. So this is this, or we can simply say if we take 25 out, it is 1 comma 4. Understood? So this is the way we have to do the calculation. So let's move ahead. We have this multiplication question. Okay. So a theta is cos theta minus sin theta. This is a alpha into a beta is equal to a alpha plus beta. We have to verify this, and this also we have to verify. Okay. So if we consider a alpha into a beta, what will we do? Simply cos alpha minus sin alpha cos alpha cos beta minus sin beta cos beta, multiplying this row with this one. We are cos alpha cos beta minus sin alpha sin beta cos alpha minus sin beta minus sin alpha minus sin beta sin alpha cos beta plus cos alpha sin beta sin alpha minus sin beta plus cos alpha cos beta. If you see it further, this is cos alpha plus beta minus this is sin alpha cos beta, okay, which is sin alpha plus beta. This is sin alpha plus beta. This is cos alpha plus beta. If you see it further, it is simply a alpha plus beta. In place of theta, we have kept alpha plus beta. Now what will happen? Can we say that if we go as a beta and a alpha, it is going to be somewhere beta plus alpha. If it is beta, it is alpha. It is going to be beta plus alpha, which is the same. Hence proved. Happy New Year, everyone. Happy New Year, everyone. Okay. So this is the way it is going. Let's move ahead. Properties of matrix multiplication. So in properties everything would be written, okay. No, a alpha plus a beta, this is we are studying the matrix multiplication, so we can't go with a alpha plus a beta, okay. So properties of matrix multiplication, okay. First property comes out to be like if A is m cross n, then B should be n cross L. That means n and n should match. Row of A should be equal to row of B. For AB to take place, okay, and if AB has taken place, the resultant will come out to be m cross L. So from m cross n cross L, the resultant is coming out to be m cross L. Got it? Okay. So C is coming out to be m cross L. So this is what I'm trying to say. This is the property, okay? Now, second property, AB is not equal to BA necessarily. Okay, if you go this way, it is not necessary that it is going to be equal or not equal, okay, but generally it is not equal, okay. Third, ABC is equal to ABC, this we can say, okay. So this will come out to be important property, because sometimes we may face confusion, because if this is not possible, then in this we are having something possibilities, we are following associative law. So this is associative, isn't it? So associative law is true for multiplication. That is our conclusion. If in exam we get a question that is associative law true for multiplication, matrix multiplication, then answer is true. Is symmetry law true for multiplication? It is false. So this is the way it will come in exam, okay. Fourth, A into identity matrix could be written as identity matrix into A, okay. So what will happen if it is n, that means n into n, so this should be m into n, okay. This should be n into n itself, because this should be n into n, okay. Then only n and n possible both in both the case, which is equal to an, okay. This is the fourth property. Fifth one, fifth Fifth one is if AB equal to IN, then we can have B equal to A inverse if determinant of A is not equal to 0. And similarly, if we have BA equal to IN, that will imply again that B equal to A inverse if determinant of A is not equal to 0. Okay, so this will come in inverse. We'll study in depth in this. For now you understand this one. Okay, sixth property. Yes sir, tell me the property. So it is lambda A into B is lambda AB, which is equal to A lambda B, where lambda is constant. Seventh, A B plus C is equal to AB plus AC. Okay, so what will happen? B and C are comparable. So if addition is happening, then it should be comparable. And if it is M cross N, then this should be N cross L. This is now we know already. Yes, so we don't have to write in every statement. Okay, this is 812. A plus B into C is AC plus BC. We know everything, they are comparable, their rows and columns should be matching. So this is all we know. Yes, and we'll go with few notes. If we are given A square, this means A cube, meaning A, A4, A, dot dot dot. Okay, okay. Second, if A is M cross N, if A is M cross N, then we can say that A M cross N should be I N cross N, which is A M cross N, or if it is I, then it should be M cross M with I with A M cross N, and it will be A M cross N. If A is of this order, that means if I is multiplying from left side, then it should match this one. If I is multiplying from right side, it should be of this form. So this is the simple thing. Normally in this case of multiplication, you will not find A into I. So when I is appearing in some question, then A should be square matrix only. So in our syllabus, it is going to happen in that way. Okay. So properties of multiplication done. Now this is the good question in multiplication. It will help you to get expertise in complete matrix multiplication. So what will happen? We have to find A cube. So A cube meaning A. It is 1, 3, 4, 2, minus 2, 2, 3, 1, 1, it is again 1, 2, 3, 3, minus 2, 1, 4, 2, 1, again 1, 3, 4, 2, minus 2, 2, 3, 1, 1. Multiply this one, okay? So we have few calculations, so we will do it in our mind. 1 into 1, 3 into 2, 3 into 4. We'll add all those three, yes. So 1 plus 6 plus 12, 19, okay? Now 1 into 2, 2 into minus 2, 3 into 2, 6 minus 4, 2, 2 plus 2, 4, 3, 2, 5, 5 plus 3, 8, 3 minus 6 minus 3 plus 4, 1, 6 plus 4, 10, 10 plus 2, 12, 9 minus 2, 7, 7 plus 1, 8, 4, 6, 10 plus 8, 14, 8 minus 4, 4 plus 2, 6, 12 plus 2, 14, 1, 15, 1, 3, 4, 2, minus 2, 2, 3, 1, 1. I think this much is enough. This place is enough for this calculation. So you remember that we have no a square, we have only a. So that is why nothing. So we are safe. 19 plus 12 or 31 plus 32, 63. 18 minus 8, 38 minus 8, 30, 30 plus 16, 46. 57 plus 4, 61, 61 plus 8, 69. 1, 36, 37, 37 plus 32, 37 plus 32, 69. 12 minus 24, 12 minus 24 is minus 12 plus 6, minus 6. 3 plus 12, 15, 15 plus 8, 23, 14, 18, 32, 32 plus 60, 92. 28 minus 12, 16, 16 plus 30, 46. 42 plus 6, 48, 48 plus 15, 63. Now a cube is this one, minus 23a is minus 23 minus 46 minus 69 minus 69, 46 minus 23 minus 92 minus 46 minus 23, and we have minus 40i, which is minus 40, 0, 0, 0, minus 40, 0, 0, 0, minus 40. If we add all of them, a cube minus 23a minus 40i, which is equal to, I think we are going to get everything cancelled, which is 0, 0, 0, 0, 0, 0, 0, 0, 0, which is capital O. Got it? Now we are on transpose of matrix. Okay. So transpose of matrix is if we perform transpose on a given matrix, we simply exchange rows of a given row with the column. Okay, that means aij is equal to aji. Okay, this is what we do. So if a is a11, a12, a13, a21, a22, a23, a31, a32, a33, if we do a transpose, this is 1 1, this will go to 1 2, so it will become a11, a12, a13, and this will become a21, a31, a22, a32, a23, a33. So we change this row in this column, this row in this column, this row in this column. That's the transpose. So simply we have to show the transpose of a matrix. If A is this, B is this, verify AB transpose is equal to B transpose A transpose. So first we'll perform AB. A is -2, 4, 5. This is 1, 3, -6. So we'll see that this is 3 row, 1 column, and this is 1 row, 3 columns. So this and this is matching, and the resultant is going to be 3 3, isn't it? The resultant is going to be 3 into 3, -2 into 1, -2 into 3, -2 into 6, 4 into 1, 4 into 3, 4 into -6, 5 into 1, 5 into 3, 5 into 6. Okay, now we'll do A B transpose, which is what? We'll change row with the column. -2, -6, 12, 4, 12, -24, 5, 15, -30. So this is whole transpose. Okay, this is whole transpose, and we write transpose in this way also. So if we want, this could be written as A somewhere dash prime type of thing. Okay, this is our AB transpose. Now we'll go with B transpose. B transpose is what? We'll change row with the column. 1, 3, -6, and we have A transpose, which is what? -2, 4, 5. So now we'll multiply B prime A prime, which is 1, 3, -6, -2, 4, 5. If you multiply, we are going to get, this is 3 row 1 column, this is 1 row 3 column. So the resultant is going out to be 3 row 3 column. Okay, so if you multiply, it is minus 2, 4, 5, minus 6, 12, 15, 12, minus 24, minus 30. So if you see, both of them are same. So that means our verification has been done, isn't it? Now we have this question. This is previous year JEE advanced question. Okay. So A, B, C, D be real matrices such that A transpose is B, C, D, B transpose is C, D, A, C transpose is D, A, B, D transpose is A, B, C. So M is A, B, C, D. Okay, now see. If is we go, this is IIT advanced question, okay? IIT advanced question. So if we perform uh, in if this is A transpose, which is B, C, D. If we perform A transpose transpose, which is A, can we say it is B, C, D transpose? We studied from the question that AB transpose is B transpose A transpose. So we'll take BC together. We'll get D transpose, BC transpose, and again if we do BC transpose, it is what? D transpose, C transpose, B transpose. That means it has come out to be negative in reverse direction. So now A is what? D transpose. D transpose is what? A, B, C. C transpose is what? D, A, B. B transpose is what? C, D, A. If you see that this A and this A could be cancelled, that means I is equal to AB CD whole square, isn't it? Okay, so M is given as ABCD. If we square, M square is ABCD whole square. Now if we square 1008 times, this is M 1000 2016, which is A square is what? I to the power 1008 is I only. So now what will happen? Can we say that I is M square? I is M to the power 4. So we got option as B and D. So this is the question from IIT Advanced. Now this is the question we have to solve. Let P is distinct, P transpose is distinct, P transpose AP is distinct. So we'll solve this question. Uh, 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 uh. P transpose. It is what? 2 6A 3 2B 6 minus 3C, and P transpose is normally 2 3 6 6 2 minus 3 A B C. This is going to be a diagonal matrix, isn't it? Diagonal matrix meaning all the elements are 0. This and this is there, otherwise it is 0 0 0. So let's solve this one. Okay, so boss, it will come out to be 4 9 13 49. 12 plus 6, 12 plus 6, 18, 18 minus 0 0. 2a 3b and 6c. 6 12, this will come out to be 0 and this will come out to be 49 if you multiply, and simply 6a plus 2b minus 3c, this is what it is. And if you multiply, this is 2a plus 3b plus 6c, and if you multiply 6a plus 2b minus 3c, and if you multiply this one, it is a square plus b square plus c square. Okay, so we got some term here, maybe z, x, y, and all are 0. We'll compare this and this. So by that we are getting 2a plus 3b plus 6c equal to 0. From here we are getting 6a plus 2b minus 3c equal to 0. Okay, okay, got it. And all terms are xyz. Now what will happen? A11. A11 is what? In a matrix A. Where? In a matrix A. Okay. P transpose is diagonal matrix. So is there space left? Okay, transpose space is left. Okay. So we are moving here. Okay. We are given that P transpose A P is 49I. Now if we multiply P transpose A P transpose, can we say it is 49? We multiplied P transpose, this is P transpose. If you see, it is something diagonal matrix A. Okay, okay, and this is diagonal matrix. So this is 49 x y z 0 0 0 0 0 0, and this is diagonal matrix A P transpose P transpose. For we'll take it like this. Okay, it is x y z 0 0 0 0 0 0, and A is somewhere A11 A12 A13 A21 A22 A23 A31 A32 A33, and this is x y z 0 0 0 0 0 0, and we have 49 x 0 0 0 y 0 0 0 z. So we can simply cancel this one and this one, isn't it? Okay, we can cancel. So we are simply, if you see, what are we getting? We are getting a11 x a12 x. If we are multiplying, what we are getting? Okay, a13 x a21 y A22y, A23y, A31z, A32z, A33z, which is equal to 49i. Yes, 0 0 0 0 0 0. So if you see previous equation, this is x, y, z. So x is 49, y is 49, z we don't know. So if you go here, x is 49. So that means if we are getting here, we take x common, 49 cancel. This is okay. X is common, y is common. Okay. You will take 49 common and divide this side. We are getting what? A11. 49 by 49 1. A12. A13. And y is also 49. So A21. A22. A23. And here also z is same. So we can say that z by 49. A31. Z by 49. A32. Z by 49. A33. This is equal to 100,010,001. And if you see in the equation, what are we given? We are given a11 plus a22 is 0 and a33 is 1. So a33 is 1. That means we can say that z is equal to 49, which is what? A square plus b square plus c square, and a11 plus a22 is 1. A11 plus A22 is 0. That means we don't have to care about this. We got from here simply A33 is 1. A33 is 1. That means Z by 49. A A33 is 1. So Z by 49 is 1. That means A square plus B square plus C square is 49. So we got that A square plus B square plus C square is 49. Okay. This is what we got. Okay, we got it. A square plus b square plus c square is 49, and all are somewhere like this. Oh, so now what will happen? What will happen? Let's see. Wait. We have to find determinant of this. So determinant of p transpose is nothing but determinant of p whole square, and determinant of p is what? This is 49, 49, 49, 49 cube. So p determinant of p is 343. So we got option 1 correct. This is option A. For option B, we have to find the value of mod A, mod B, mod C. Okay. So if we pick any one of, if we pick this and this, we multiply this with 2 and add with this. So 6c gone. So we are getting 2 plus 14, 2 plus 12, which is 16, 3 plus 4, 7. So we are getting 16a multiplied 2 times. 2 plus 14, 16a, 3 plus 4, 7b, which is equal to 0. We can say a equal to minus 7 by 16b. And if you put this thing, a and b here, so we'll get some value of c. Okay. We'll get some value of c. So determinant of mod of a, mod of b, mod of c. We are getting some rough answer. So what the value of c will be? Let's skip here. A is minus 7 by 16, which is minus 21 by 8, it will go 16, minus 5 by 8, minus 5 by 8, it will go that side, 5 by 24, this is minus 5 by 24b. So now if you put this thing, simply trace of b is what, 49 into 3, trace of b is x plus y plus z, which is 49 into 3, so this is correct. A P P transpose, we don't have to do this much multiplication, okay. D number is, D is A P P transpose. What is this? Is a diagonal matrix. So this is a diagonal matrix we have to prove. So we know that PA P transpose is 49. If we multiply P, this is P, so P P transpose is 49. So 49 49 cancel. So we are left with P P cancel. So A is what? I. So I is what? Diagonal matrix. That means A P P transpose is what? Diagonal matrix. A is I. So P P transpose is diagonal matrix. So A is what? Diagonal matrix. So we got option C, option D. Now A is what? So we know that A square plus B square plus C square is this thing. So we have 49. A square is what? 7 by 16 B square. So 49 by 16 whole square. B square is 1. C square is 5 by 24. 25 by 576. This is B square. This is 256. So what will happen? This is 16. This is 24. So we'll multiply 9 here. We'll multiply 3 here. We'll multiply 4 here. So I think A, B, C. What will happen? Let's solve it, okay? Hmm, this is not going. Okay. What I'm trying to say is that it is 49 by 16 whole square, which is 196. 16 is 8 2 ja, and this is 8 3 ja. So we'll multiply 9 divide 9, and there we'll multiply 4 divide 4. So it is somewhere we are getting 49 equal to something 576 into 4, and this is we are going to get 9 9 ja 81, 9 4 4 1, and here we are going to get 6 4 ja 5 7 ja 28, 1 30, 28 to 30, 23 plus 100, and this is b square. Okay, this is 441. So we are getting somewhere, if we solve it, I think we'll get some value. And mod A, mod B, mod C is going to be 11. Okay, if you calculate, we are going to get it. Okay. Mm, okay, we are going to get it that thing. Okay, A, B, C, D is the answer. Now properties of transpose. So properties of transpose, we'll solve it. Okay. 1. For any matrix A transpose transpose is A. Okay. Second, lambda A transpose is equal to lambda A transpose. Okay. Third, A plus B transpose is equal to A transpose plus B transpose. And if you go in a generalized way, A1 plus A2 plus A3 plus dot 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 AN transpose is A1 transpose A2 transpose dot 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 AN transpose. Yes, and we can generalize it more way, plus minus 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 plus minus. Happy New Year, Akshaj. Okay, Happy New Year. Okay. Fourth one, okay, we generalized AB transpose is equal to B transpose A transpose. If we want to generalize it, general A1, A2, A3, AN transpose is AN transpose, AN minus 1 transpose, AN minus 2 transpose. It is in reverse direction. A3 transpose, A2 transpose, A1 transpose. It is in reverse direction. Simply just we are trying to say it. Okay. So this is the properties of transpose. Now we are on skew symmetric and symmetric. Okay. Symmetric and skew symmetric. Okay. So in symmetric, if we are going with symmetric, okay, okay. So symmetric matrix. If A transpose is equal to A, it is called as symmetric matrix. Only this much. A transpose equal to A. This is symmetric matrix. Okay. And second, I am giving you example meaning if we have A equal to A B C H G H G F F. If you do A transpose, it is going to be the same, I think. A H G H B F G F C. So if they are equal, yes, A transpose is equal to A, so that means they are symmetric. Second, skew symmetric. So the concept are simple, okay, but the question which are asked, they are really going to be a bit difficult. So we have to do A transpose equal to minus A. A transpose equal to minus A. That means what? That means A is equal to, if it is A, B, C, A, B, C, we'll keep it minus E, minus F, minus G. So it should be E, F, G. So if you do A transpose, it is what? A, B, C, minus E, minus F, minus G, E, F, G. So we are told that they should be A transpose should be equal to minus A. Can we further say that it could be A transpose plus A equal to 0? So if A transpose is equal to 0, then it could be symmetric. So skew symmetric, then what will happen? Let's proceed. A plus A transpose. It is what? It is A, 2A, 2B, 2C. This is what? 0, 0, 0, 0, 0, 0. And A transpose is 0. That means can we say that A is 0, B is 0, C is 0? So from here we'll understand one thing. The thing is the diagonal element of skew symmetric matrix is 0. Okay, that means in a skew symmetric matrix, okay, we'll write this here. In a skew symmetric matrix, diagonal element is 0. Diagonal element is all 0. Okay, that we'll write this in properties also. Okay, so let's move ahead. Show that B transpose is symmetric or skew symmetric according as A is symmetric or skew symmetric. So for that we'll take C equal to B transpose. We'll do C transpose, which is B transpose. Now based on property, we know that this will go in the reverse order. B transpose, A transpose, B transpose. which is what? B A transpose B transpose. This is what it is. Now it is told that if A transpose is A, then C transpose will come out to be B A B transpose, which is C. So if A is symmetric, then C transpose is C, which is symmetric. So it is depending on A. If A is skew symmetric, then C will come out to be skew symmetric. If A is symmetric, then C will come out to be symmetric. Now if A transpose is minus A, we are going to get C transpose at, in place of A we'll put minus A, which is minus B A B transpose, which is minus C. So it is correct. So we could prove that if A is symmetric, C will be symmetric. If A is skew symmetric, C will be skew symmetric. Next question. Show that A transpose are symmetric. So similarly to the previous one, we'll take A equal to A transpose. We'll do C transpose, which is nothing but A transpose, which is written in reverse order, which is A transpose transpose, which is nothing but A transpose A, which is C. So this is symmetric. Similarly, similarly, if we take C equal to A transpose, on doing C transpose, we are going to get A transpose transpose, which is A transpose. This is A transpose of transpose in reverse direction, which is A transpose, which is C. So we are getting C transpose equal to C transpose equal to C. That means symmetric matrix. Now I will leave this question on you. You will take C equal to AB plus BA. We will take transpose. I am doing one of them. I will consider C equal to AB plus BA. And I am doing C transpose. It is what? AB plus BA transpose, which is nothing but AB whole transpose plus BA whole transpose. If you solve it, it is B transpose A transpose, and this is A transpose B transpose. We are given that A and B are symmetric. That means B transpose is B, A transpose is A. So if you see that it is normally C, that means C transpose came out to be C. That means it is symmetric. For skew symmetric, we have C transpose. We will first have C equal to AB minus BA. C transpose will come out to be AB minus BA whole transpose, which will come out to be AB transpose minus BA transpose, which will come out to be B transpose A transpose A transpose B transpose. We know that B transpose is B, A transpose is A, minus A transpose is A, B transpose is B. If you see, if you take minus, it is AB minus BA, and in place of AB minus BA you can put C, which is minus C. So C transpose is equal to minus C, which is skew symmetric. We proved it. Now this is the question. We'll have to solve it. First, A is n cross n, so we have to first find the matrix This is n cross n, which could go to infinite level also. So we should show that it is skew-symmetric. So what will happen at the center? It is going to be 0, 0. And based on the property we studied that the diagonal element here I is equal to j. So diagonal element is 0. That means it has some criteria to become skew-symmetric, isn't it? Now, if we go here, it is first row, second column. That means it is 1 square minus 2 square. And if you come here, it is minus of 1 square minus 2 square. It is second row, first column. That means 2 square minus 1 square, which is minus of this. So similarly, if you go here, it will come out to be 1 square minus 3 square. And here it will come out to be minus of 1 square minus 3 square. So similarly, if you move ahead, move here, we are going to face the same thing. So if this element is negative of this one, if these elements are negative of these elements, so we can have A transpose equal to minus A. And if it is possible, then this is skew symmetric. Got it? Properties of skew symmetric. Okay. We have given enough place for properties that I'm looking. Okay. Properties of skew symmetric. So one property, in a skew symmetric matrix, all the diagonal elements are 0. Second, what will happen? We are told that A plus A transpose is symmetric and A minus A transpose is skew symmetric matrix. Skew symmetric matrix for all matrix A. Okay. So if you try to find it like putting C equal to A plus A transpose, okay, you will find that it is going to be symmetric only and this is going to be skew symmetric. Okay. So now from this point, we can say that any matrix, any matrix A could be represented as 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose. Isn't it? Yes. Now if you see, can we say this is, if you see here, A transpose was symmetric. So can we say that any matrix could be represented as the sum of two, the sum of symmetric and skew-symmetric matrix. Okay, any matrix could be represented as a sum of symmetric and skew-symmetric matrix. Okay, can it be? Because if you see 1 by 2 common, A transpose is cancelled. This is 2A by 2, which is A, and we know that this is symmetric, this is skew-symmetric. We'll get question in mains. In mains, we'll get question from this point. Got it? So I am taking one example. One question is that A is equal to 1, 2, 3, 4, and A is equal to P plus Q, where P is symmetric matrix and Q is skew symmetric matrix. Then find P and Q. We know that A is equal to half A plus A transpose plus half of A minus A transpose. And can we say that this is skew symmetric, which is Q, this is symmetric, which is P. So can we say that P is equal to half A plus A transpose? So we'll have to do, okay, A is 1, 2, 3, 4. A transpose is 1, 2, 3, 4. If you add it, it is 1 plus 1, 2 by 2, 3 plus 2, 5 by 2, 3 plus 5, 3 plus 2, 5 by 2, 4 plus 4, 4. Okay. Similarly, if we go for Q, it is 1 by 2 A minus A transpose, which is simply 1 by 2. A is 1, 2, 3, 4, and minus A transpose is 1, 2, 3, 4. It is what? 1 by 2. 1 minus 1 is 0. 4 minus 4 is 0. 2 minus 3 minus 1. 3 minus 1, 1. And see, this term are coming out negative and diagonal element is 0. So can we say it is skew symmetric by our properties also? So this is simply 0, 1 by 2, minus 1 by 2, 0. Got it? So we are done with skew symmetric. Now we are on submatrix. Okay. So we are planning to have some break. So we are going to have some break, okay, and after that break we are going to continue our class. Okay. Mm, so we'll continue our class. Okay. So we are going to have around 15-minute break. So break for 15 minutes. Return at 1:45 p.m. So we'll return back at 1:45 p.m. So have a break. मैंने भी पे कर दिया। बेड हटा दिए बेड हटा दिए बेड हाँ थोड़े झाड़ू मारे तो काम खत्म होता है झाड़ू मार के क्यों रख दिए हाँ क्योंकि सोने का अच्छा अपना कंबल डाल डाल दीजिए बोला बोले यही का तो बोला ले जाइएगा तो क्योंकि देखने घर आइए देखते हैं खाना खाए नहीं नहीं खाइए 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 अभी नहीं मैं काम से हाँ काम तो इसमें आता है इसमें ये भी नहीं दिख रहा है ना इस काम में उसी नाम को कांग्रेस का फोटो मिल जाए आपको भी हाँ हमारा कंबल देखते हैं इसके अंदर कंबल नहीं कोई कोई कंबल आइए तो क्वेश्चन करेंगे हम कंबल देखते हैं इसका और कंबल को आपको जरूरत नहीं बैठना काम कर नहीं मेरा भी काम है और खत्म करना है नहीं 15-20 मिनट के अंदर खत्म करना है मेरा खाने खत्म हो जाएगा तो स्लीपर पे छुट्टी नहीं रिवर छुट्टी का इसका टारगेट भी दे दिया ना तो 50 में थे ना हम 50 में थे फिर रखी जा रहा थी कल पैसा नहीं था जो क्योंकि 3 दिन लगे और सैलरी अच्छा सैलरी हम पुराना होगा मैं इस महीने में अरे दे दिया आपको दिया है ना नहीं है 3 दिन ले हां मेरा सेविंग था वो नहीं अभी मेरा अकाउंट में ऐसे हम बोल रहे थे यार कि अभी आप सिर्फ सेविंग दी है सब तो सेविंग नहीं देता हाँ मेरा सेविंग खत्म हो गया पूरा खत्म दिन हाँ 500-600 रुपया होगा ये हफ्ता चल जाना चाहिए बस ऐसा कैसे मेरा लोन भी जाता है ना लोन का पैसा कट गया ईएमआई हाँ बोले थे ना आपको मेरा लोन का पैसा कट गया कितना कटता हूँ मैं इसका मेरा महीना में 8,000 लोन हाँ 10,000 हाँ बाप रे घर भी पैसा लेते नहीं आप भेजते हैं क्या भेजना पड़ता मेरा नहीं वो घर में मेरे घर वालों कहना है अपना ईएमआई की तो वही का तो भी कितना बचा हुआ पैसा मेरा 2 साल बाकी है मेरा कितना पैसा बचा हुआ है देने का लोन तो 1 लाख कुछ है वो तो पापा ही बोल रहे हैं कि हम दे देते हम जरूरत नहीं हम ही हमें पापा तो बोले कौन सा दाल डाल वही जो बोले थे आप गुजरा होगा हाँ जैसे दाल बना ना दाल बना नहीं वो तो ज्यादा चाहिए सोना ये करता है तड़का वाला दाल देखो नहीं हाँ मैं अभी कहाँ से बनाएगा मेरा काम जरूरी है चादर उठा लीजिएगा। किसका किसका आपका अच्छा अपना चार्ज दीजिए। हाँ खा के थे। हाँ खा के थे। खा लीजिए पेपर दे पेपर 10 मिनट का। ऐसा करेंगे ना आप खा लीजिए हम सर डाल के रख आपसे ऑन कर दीजिए। जो प्ले एंड पाउज वाला है ना स्टार्ट एंड ऑफ वाला उसको कर दीजिए। वो प्ले हाँ प्रेस हाँ बोल वाला से पहले में जो ऑफ के नीचे वाला नहीं है उसको दबा दीजिए। लेकिन नहीं नहीं कौन सा आगे निकला एक यहाँ पे। So okay, I think hopefully everyone might have done their breaks, and now they are ready to come back. Okay, so we'll start with submatrix. So by the word, if you could understand, submatrix is just a small part of a matrix. A small part of a matrix. So submatrix, the matrix which is obtained by by deleting few rows and columns of a given matrix. Okay, if a matrix is A, which is, for example, A, B, C, D, and this is X, Y, Z, W, P, Q, R, S. Now we have to find sub matrix, sub matrices. So what will happen? We'll delete this row and this row, this column and this column. Can we say after deleting we are getting A, X, P, D, W, S. Okay, we delete this row, we delete this row. Okay, this column, we are going to get A, B, D, X, Y, W, P, Q, S. Okay, and now we delete this row. Okay, so we are getting A, B, C, X, Y, Z, P, Q, R. Okay, so these are the submatrices. Okay, that's all submatrices. Let's move ahead. Minor and cofactor. Okay, so what will happen in order to find minor? This is a minor. Okay, minor and cofactor. We are given a determinant A. we are given a matrices A. Okay, matrice. Okay, A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, now we have to find minor of A11. So minor of A11 is what? We'll delete this row and this column. What are we getting? A22, A32, A23, A33. Okay, this is what we are getting. Now what will happen? We can, to find this value, we'll have to simply cross multiply and put minus in between. So A22, A33 minus A23, A32. This is minor for A11. Minor of A23. Okay. We'll delete A23 row and A23 column. What are we left with? A11, A31, A12, A32, and if we find, we'll just cross multiply and write it. A11, A32 minus A12, A31. Okay, so this is the minor for this. Now, tell me any minor. Minor of A32. Okay, so we'll delete this row and this column. What are we getting? A11, A21, A13, A23, and we have to find this value, which is what? A11, A23 minus A21, A13. So these are the minors. Okay. So we got the minor. This is for 3 into 3 matrices. If we talk about 2 cross 2 matrices and we are trying to find minor, so if we take A equal to A11, A12, A21, A22. So if I want to tell you to find minor of A11, so what we know from the previous one, we'll delete this row and this column. What are we left with? A22. So minor of A22. We'll delete this row, this column, we are left with A11. So all the A11, A12, they are all some value, some real number, okay? So that real number is happening here. Similarly, if I tell you minor of A21, so second row, first column deleted, we are left with A12. Similarly, minor of A12, delete this row, this column, we are left with A21. So these are the minor. You all Just see it. If you have any doubt, you tell me. I am giving you 1 minute of time to think on this, okay? So kindly think on this. I am giving you 1 minute of time. Then I will move to cofactor, okay? Hello? हेलो हाँ बता मुझे हैप्पी न्यू ईयर हाँ ठीक है अरे तो रूम में छुट्टी है हम्म, हम्म, क्या हाँ कर रहे हैं अभी ऑनलाइन पढ़ा रहे हैं हुआ देख लेते हैं So I could get that none has any doubt in this. So we'll move to cofactor. Okay. So let's move to cofactor. So what will happen? We'll take the same case and we'll try to find cofactor. So what will happen? This is minus minor 1 1. We can write this as minor 1 1, minor 2 2, minor 3 2. This is called as minor 1 1, minor 2 2. So this is 2 row 2 column. So minor 2 1, minor 1 2. Okay. Now we are moving to next. We are told that now find cofactor. Cofactor C11. That means for A11. So cofactor meaning C11. Okay. So cofactor C11 meaning we are telling cofactor. Okay, let's say we'll tell cofactor of A11. Cofactor of A11 will say cofactor of A11 which is represented as C11 will be nothing but minus 1 to the power 1 plus 1 M11. Okay. If I tell you cofactor of A21 which will be represented by C21 which is nothing but minus 1 to the power 2 plus 1 M21. For example, if we take A11, this is this thing. So if you come here, it is nothing but equal to M11. It is nothing but equal to M21. And it is valid for not only 3 into 3 matrices but also for 2 into 2 matrices. So for example, now we have to go here and I am finding C11. This is equal to C11 And can we say M22 is equal to minus C? No, it is 2 plus 2, which is C22. This is equal to minus C32. This is equal to minus 1 plus 1 is 2. If it is even, this is C11. If it is even, this is C22. If it is odd, it is minus C21. If it is odd, it is minus C12. So this is the way we have to find cofactor. Okay, we have to just have minus 1 to the power 2 plus 1 like this, and whatever minor we found, we'll keep that value and we'll get the cofactor. Okay, now we'll take one question on this. So sum up what you did not understand. So we have to find the minor of 3 1, minor of 3 1. So they simply gave you us 3 1. Minor of 3 1 is of in the determinant is equal to 1. So what is minor of 3 1? Third row, first column. That means delete this one, delete this one. We are left with 1 minus sec alpha, tan alpha. We will solve this. We'll just cross multiply tan alpha minus of minus sec square alpha, which is sec square alpha. If you see it, it is nothing but tan alpha plus 1 plus tan square alpha. If you solve it, we'll get 1 equal to 1 plus tan alpha into 1 plus tan alpha. So 1 and 1 cancel. We are getting 0 equal to tan alpha plus 1. So we are getting tan alpha equal to 0, tan alpha equal to minus 1. So from here, can we say that alpha is 0 and pi? From here, can we say alpha is pi minus pi by 4, which is 3 pi by 4? Okay. So these are the things we got it. So we have 3 solutions. Let's move ahead. Now determinant of 2 order. Determinant of matrix of 2 order. Okay. So order 2 meaning what? 2 into 2. We should know that we can calculate the determinant of only square matrix. So if it is 2 order, that means it is 2 into 2. So if we have A equal to 1 1, A12, A21, A22, the value will come out to be cross multiply with minus in between. A11, A22 minus A12, A21. Okay. For example, we are taking A equal to 1 2 2 1. So we have to find the determinant of this. Determinant of A. It will be 1 into 1 minus 2 into 2 equal to minus 3. Note that this is not mod, this is determinant, which can come out to be negative also. Got it? So note determinant value could come out negative also. Got it? Let's move ahead. Determinant of a matrix of order 3. So order 3 meaning it's a square, 3 into 3. So A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. So if you want to find the determinant of A, which is also written as det of A, which is nothing but A11 into cofactor of A11 plus A12 cofactor of one row second column A13 cofactor of 1 3. Choose any row and multiply it with their cofactors. So I chose A11, I multiplied with its cofactor. A12 I multiplied with its cofactor. So I chose this one. Or you can choose any column. Choose any row or any column. So for any column I am choosing, for example, this one. Or first we take this one only. So it could be written as A11, C11, A21, C21, A31, C31, or I am choosing this row. Any row meaning this row, okay? Or this row. Which row should I take? I am taking the third row. Let's take it, okay? A31, C31, A32, C32, A33, C33, or I am taking any row, any column. So I am taking the third one only, or the second one. Let's take it second one. A12, C12, A22, C22, A32, C32. So this will also give you the value of determinant. This will also give you the value of determinant. This will also give you value of determinant. This will also give you the value of determinant. So let's proceed. So I think we are given to take some question. So let's take some question. A is one, two, three. 1, 2, 3. 1, 2, 3. Okay. Now we have to find the determinant of A. Find A equal to what? So determinant of A. So I am going to choose the first row. Okay. So determinant of A is A11, C11, A12, C12, A13, C13. So C11 is what? Minus 1 to the power 1 plus 1 M11. So minus 1 to the power 2 is what? 1 only. So M11 is what? So first row, first column eliminate. This is A. We are getting 2, 3, 2, 3. If we cross multiply, it is 2 into 3 minus 3 into 2, which is 0. C12 is minus 1 to the power 1 plus 2, M12. So first row, second column, both will be eliminated. We are left with what? 1, 1, 3, 3. If you solve it, it is what? 1 into 3 minus 3 into 1, which is equal to 0. C13 is what? Minus 1 to the power 1 plus 3 M13. Okay. So we are going with first row, third column elimination. So we are left with 1, 1, 2, 2. If you solve it, it is 1 into 2 minus 2 into 1, which is nothing but 0. So if we put in this, A11 is 1, C11 is 0, plus A12 is 2, C12 is 0, A13 is 3, C13 is 0. So the value of determinant is what? 0. So I think you got it. Yes. So let's move ahead. So transpose of determinant is similar as is same as transpose of matrices. So we'll write it. If A is A, B, C, D, E, F, G, H, I. So A transpose is A, B, C, D, E, F, G, H, I. So what will happen? In transpose, we will exchange rows with the corresponding column, or we can say that Aij is equal to Aji. We did this in previous while solving the determinant. So in determinant we are going to write it a straight line. Okay, this is a straight line, this is a straight line, this is not a rectangular box, this is a straight line. Okay, this is the meaning of determinant. Got it? Let's move ahead. Now it's time for properties of determinant. Okay, so we have around 10 different properties of determinant. Okay, so we have 10 different properties. Okay, so let's start with the properties. So first property is determinant of A is equal to determinant of A transpose. Okay, this is the first property. Okay, if you want example, so we got the example previously. What is the transpose or determinant? Okay, second, if we interchange any two rows or two columns, if we interchange any two row or two column, the value of determinant will be multiplied by -1. Okay, so I will be taking one example here. If a determinant A is A1, A2, A3, B1, B2, B3, C1, C2, C3, and if the second determinant is made with the interchange of this row and this row, which is B1, B2, B3, A1, A2, A3, C1, C2, C3. If you see that they are interchanged, then we can say that A is equal to minus of B. Okay. Now what will happen? We'll again make one BC and we'll interchange this one. So this is B1, B2, B3, C1, C2, C3, A1, A2, A3. So we made change in this determinant. That means C will come out to be minus of B, and can we say hence A equal to C equal to minus B. So if we are changing odd numbers of interchange, then then this is determinant of A, this is determinant of B, this is determinant of A equal to determinant of B, this is determinant of C, this is determinant of B, this is determinant of A, this is determinant of C, this is determinant of B. So then determinant value will get multiplied by -1. Okay, okay, this is it, else it is the same. Okay, now we are moving to third property. What is third property? In matrices, if you remember, if you multiply any constant, it used to get multiplied to every element but in determinant. Indeterminate. Multiplying any constant will will multiply to any of one of the row or column. If we multiply some constant to a determinant, it will get multiplied to any one of the row or column. Okay. For example, if it is determinant A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. If we multiply lambda, determinant of A, it will come out to be, choose any one of the row. I am choosing first row, which is lambda A11, lambda A12, lambda A13. This is A21, A22, A23, A31, A32, A33. Or I am trying to multiply to any other column maybe. So I am choosing the middle one. So it could even be written as A11 lambda A12 lambda A22 lambda A32, and this is A11 A21 A31 A13 A23 A33. Or you can choose any one of the row. I am choosing the third row A31 A32 A A33 lambda. This is A21 A22 A23. This is A11 A12 A13. Okay, so this is the third property. We are moving to fourth property. Fourth property is determinant of AB is equal to determinant of A, determinant of B. This property is very much important. Remember this. Okay. Okay. Now we are going to fifth one. Determinant of lambda A. So what will happen? Lambda is a constant. Okay. So lambda is constant. It will come out to be lambda to the power n determinant of A. So lambda is constant and order of A is n. Okay. Got it? Sixth one, determinant of odd order matrix. Odd order skew symmetric matrix is 0. Okay. Simply we know that A transpose is minus A. If you take determinant both the side, it will come out to determinant of A equal to minus of determinant of A. If you solve it further, can we say 2 determinant of A equal to 0? Can we see that determinant of A equal to 0? So I think it's not only odd, for even also it will be coming out to be 0. Okay, so let's move ahead. We went to property 6. It's up time for property 7. Property 7. A determinant having any one of the row or column has all elements 0. A determinant having any one of the row or column has all elements 0. Then its value is 0. If A is 0, 0, 0, A1, A2, A3, B1, B2, B3, its value is 0. If it is 0, 0, 0, A1, A2, A3, B1, B2, B3, it is 0. That's all. Okay. 8. A determinant having any two of rows or columns are proportional, then its value is 0. Okay. Example: A is A1, A2, A3. This is K A1, K A2, K A3, B1, B2, B3. If you see they are proportional, it is K multiplied. If we multiply row 1 with K, it will get row 2. So such value is equal to 0. If you want to write more further, you can say A1, A2, A3, B1, K, KB2, KB3, KC, KA1, KB1, KC1. This is C1, and this is B3, C3. So the value is 0. Okay, that's all. Moving to property number 9. Okay, moving to property number 9. If a determinant is given as a1 plus x, b1 plus y, c1 plus z, this is a2, b2, c2, a3, b3, c3. It could be written as a1, b1, c1, a2, b2, c2, a3, b3, c3 plus x, y, z, a2, b2, c2, a3, b3, c3. Okay, so it could be written in this way. This is property 9. Okay, this is property 9. We'll go with property 10. This is the most useful property in determinant. We are told that if B1 is a determinant, A1, A2, A3, B1, B2, B3, C1, C2, C3. If we make any changes, making any changes using row operation and column operation, making any changes using row operation or and column operation is going to provide the same value of determinant. Okay, for example, in this, if I am doing row 1 tending to row 1 plus m time row 2, okay, and I am doing row 3 tending to row 3 plus n time row 2, the determinant value is going to be the same. It was what? A1, so row 1 plus m time row 2. So this is m time b1 a2, m time b2 a3, m time b3, and this is the same b1 b2 b3. This is c1 n time b1, c2 n time b2, c3 n time b3. So the determinant value is going to the same. So we perform row. In case we would have performed column, it would have come out with the same value. The determinant value is going to not change. Okay. So this is what I am trying to say using this example, this property. Okay. Moving to 10th, it was 9th, it was 10th. Now moving to 11th property. Property number 11th. Property number 11th is the sum of multiplication of elements of any one of row or column to elements of any other elements of cofactor of any other row and column is equal to 0. The sum of multiplication of elements of any one of row or element row or column of column to the cofactor of element of any other row or column is equal to 0. So this is the very important property. Normally you will make this question wrong, this type of question, so I'm trying to give it some time for everyone to grab it. So what will happen if we have a equal to, this is determinant, okay, a1 a2 a3 b1 b2 b3 c1 c2 c3, okay, and we have a cofactor matrix C11 C12 C13 C21 C22 C23 C31 C32 C33. Now what will happen if I multiply this row? Okay, if we multiply this row with the cofactor of this one, that means a1 c21 A2 C22 A3 C23. This is going to be 0. If we take this column and multiply with this cofactor, A3 C11 B2 B3 C21 C3 C31, this is going to be 0. So we have to choose complete row and complete of any row or any column. Okay. We'll put it respectively here, because what will happen if I'm choosing row? I cannot choose cofactor of any other column. It is row, then cofactor of any row only. If it's a column, then cofactor of other column only. Okay, so respectively. This is respectively, है ना? So this is the property. So we have again one property, property number 12. Property number 12 is saying that if a determinant is a function of x on putting x equal to a, the value of determinant becomes 0, then x minus a is one of the factor of determinant. Okay, got it? Got it? Understood? So I am taking one example. If we take a determinant a, 1a square, 1b b square, 1c c square. Okay, put a equal to b. If you put a equal to b, it is 1b b square, 1b b square. So two rows are equal. That means determinant of a is equal to 0. B equal to c. Determinant of a will again become equal to 0, because b, two row will become equal. If we put c equal to a, on putting c equal to a, this is a and this is a square, a square. So two rows are equal. That means determinant of a is equal to 0. So we can say that this could be written as a minus b, b minus c, c minus a. Got it? So the value of this could be a minus b, b minus c, c minus a. This is the value of this one. So this is what we are trying to say. Anyone having any doubt, they can ask me. I am ready to explain it once again. So now we are on the question. So we have to simplify. We have A equal to A B C B C A C A B. So what will happen? We will not expand it. We'll solve it using properties of determinant. Whatever properties right now we studied. Okay. So we'll do row 1 tending to row 1 plus row 2 plus row 3. So A is equal to row 1 plus row 2 plus row 3. It is A plus B plus C, A plus B plus C, A plus B plus C. And this is B, C, A, C, A, B. We'll take A, B, C, A plus B plus C common. It is what? A plus B plus C, 1 B C, 1 C A, 1 A B. Going further, in A, in this, we'll perform column 1 tending to column 1 minus column 2, column 2 tending to column 2 minus column 3. So we have what? A plus B plus C. Now, column 1 minus column 2. It is simply column 1 minus column 2 in place of column 1. So column 1 minus column 2 is 1 minus 1 0, B minus C, C minus A. Now column 2 minus column 3 in place of column 3. So it is 0, C minus A minus B. This is 1, A, B. Now we have to reduce our operation, isn't it? So what will happen if we go through this way? Second row, we'll have to take this one, multiply with its cofactor, this one with its cofactor, this one with its cofactor. Yes. So what are we doing is that we are choosing the first row such that this is 0, this is 0, and we will have to calculate for only this one. So let's continue. So this is A plus B plus C, and here we have 0 into cofactor, which is 0 only, 0 into cofactor, this is 1, and we are left with, this is first row's third column, which is minus 1 to the power 1 plus 3, which is 1 only, cofactor is 1 only, plus minus plus, and this is B minus C, C minus A, C minus A minus B. Now we'll expand this, it is A plus B plus C, and it is simply B minus C, A minus B minus C minus A whole square. It is simply A plus B plus C. This is AB minus AC minus B square plus BC. And if you see, it is C square minus A square plus 2AC. It is A plus B plus C, and this is what? AB plus BC plus AC minus A square, okay, minus B square minus C square. So this is the answer. If you have any doubt, you ask me on this, okay? Okay, so if you have any doubt, you can ask with me. Okay, so now we'll move to next question. Now let's proceed ahead. This question: A B C, A square B square C square, B C A C A B. Okay, so what will happen if we consider this equal to A? We will multiply. We'll multiply A to first column and divide A because we multiplied. We'll multiply B to second column and divide B. We'll multiply C to third column, which is A. Now what will happen? Can we take A, B, C common? And we are left with A square, A cube 1, B square, B cube 1, C square, C cube 1. So now we'll perform what? Our aim is to make this 0, this 0. So column 1 tending to column 1 minus column 2, column 2 tending to column 2 minus column 3. So we are simply getting A equal to A square minus B square, A cube minus B cube, B square minus C square, B cube minus C cube 0, C square C cube 1. Now we'll move here again. If we see in this row, A minus B is common. ABC cancel, yes. So in this row, if you see A minus B common, in this row B minus C is common. Okay, boss. This is A plus B. This is A square plus B square plus AB. This is B plus C, B square plus C square plus BC. This is C square C cube 1. Okay. Now what will happen? We'll perform again. Column 1 tending to column 1 minus column 2. We have A equal to A minus B, B minus C. If we do column 1 minus column 2, it is A minus C. This is, if we do minus B square cancel, we are going to get A plus B plus C into A minus C, I think. Let's see. Yes. And this is 0. This is B plus C. This is B square C square plus BC 0 C square C cube 1. Now in this we can take A minus C common. A minus B already common. B minus C common. We are getting 1. A plus B plus C 0. This is B plus C only. B square C square plus BC 0. C square C cube 1. We'll expand by third column, third row. On expanding, we are going to get from here. We are going to get A minus C, A minus B already there, B minus C already there. On expansion, we are getting B square. We are getting B square C square plus BC minus AB minus AC minus B square minus C square minus 2BC, which is what? B square C square cancel. We are getting somewhere AB, A minus B, A minus C, C minus B, AB, BC, CA. So this is what we are getting. Okay, let's move ahead. Now can I leave this question on you? It is a symmetrical matrix. If it is a skew symmetric, you see that this is minus of this one, this is minus of this one, this is minus of this one. So the value is directly 0. Skew symmetric. Why? Skew symmetric of order odd, or for any value it is 0. Now for this question we have to solve. Yes, so I think I should solve it. Okay, we'll consider this A. If you consider B is common, it is B minus A. A is common, B minus A. C is common, B minus A. C is common, B minus A. B is common, B minus A. A is common, B minus A. So it is simply B, B minus A, B minus A, C, B minus A, B minus C, A minus B, C minus A, C, B minus A, B, B minus A, B minus A. We can take B minus A common. This is B minus A whole square. Now we are left with B, A, C, B minus C, A minus B, C minus A, C, B, A. What will happen if we do column 2 tending to column 2 minus column 1 plus column 3? The middle term will come out to be, this term will be the same, middle term will come out to be 0, 0, 0. Hence the value is going to be 0. Got it? This one, how to solve it? Try this question. I am giving you 1 minute. Okay, try this question. So in this we are simply going to perform row 1 tending to row 1 plus row 2 plus row 3. If we see, it is going to be a plus b plus c, a plus b plus c, a plus b plus c, and this is 2b, 2c, b minus c minus a, 2c, 2b, c minus a minus b. We can take a plus b plus c common. A plus b plus c, this is 1, 2b, 2c, 1, b minus c minus a, 2c, 1, 2b, c minus a minus b. Now we'll do column 1 tending to column 1 minus column 2, column 2 tending to column 2 minus column 3. So we'll simply get it as a plus b plus c, and column 1 minus column 2 is 0. A plus b plus c, 0. This is 0. Minus a minus b minus c, a plus b plus c, 1, 2b, c minus a minus b. From here we will take a plus b plus c common, a plus b plus c common. We are getting a plus b plus c whole cube, 0, 0, 1, 1, minus 1, 0, 1, 2b, c minus a minus b. We'll expand it through row 1, which is going to be 1. So this is a plus b plus c whole cube. This is our answer. Let's move ahead. So using vector theorem we have to do this. Okay. So I think we have solved this type of question. I am showing you by doing vector theorem. We'll multiply a to first row and divide by a. We'll multiply b to the second row and divide by b. So this is somewhere a square, a, b, c, b, b square, a, b, c, c, c square, a, b, c. Now we'll take a, b, c common. It is simply a square, 1, b, b square, 1, c, c square, 1. Put a equal to b, determinant value is 0, b equal to c, determinant value is 0, and c equal to a, determinant value is 0. So simply we can say that this is a factor of a minus b, b minus c, c minus a. That's all. We are coming to this question. Very good question, okay? So how to solve this question? This is a tricky question. We'll consider this as A. Okay? And we'll break it in the form of addition. What will happen? We'll first make it like this. See. We'll make it root 3 plus root 13, root 15 plus root 26, 3 root 65. This is 2 root 5, 5 root 15, root 5, root 10, 5. We'll break it into two addition. So what was the problem? We'll break into this and this. So if we break it, it will come out to be root 3, root 15, 3, 2 root 5, 5, root 15, root 5, root 10, 5, plus root 13, root 26, root 65, 2 root 5, 5 root 15, root 5, root 10, 5. We'll take root 3 common from here. Okay? We'll take root 5 common, root 5 common. So it's like root 3, root 5, root 5. We are left with 1, root 5, root 3. 2, root 5, root 3. 1, root 2, root 5. Okay? Now if you see here, if we take root 13 common, if we take root 5 common, we are going to get 1, root 2, root 5. And here 2 root 5, 5 root 15. And here we have 1, root 2, root 5. So if you see both the column common, so the value is going to be 0. And here we'll do column 1, column 2 tending to column 2 minus column 1. We are getting root 75, 1, root 5, root 3, 1, 0, 0, 1, root 2, root 5. We'll expand it through column 2. So we know that it is root 75. It is minus 1 into 5 minus root 6, which is nothing but root 75 root 6 minus 5. This is the answer. Okay, so let's move ahead. In this type of question, this is a good type of question, so I would tell like kindly solve it for 1 minute. I am giving you 1 minute of time, and after that I will solve it. Okay, so take 1 minute of time and solve it. I am looking you all. Okay, try it. So now I am solving this question. Okay, we know that S naught is what? Alpha to the power 0, which is 1, beta to the power 0, which is 1, gamma to the power 0, which is 1. S1 is alpha plus beta plus gamma. S2 is alpha square plus beta square plus gamma square. S3 is alpha cube plus beta cube plus gamma cube. S4 is alpha power 4, beta power 4, gamma power 4. So if you see, put it here, S1, S2, S3, it is 1 plus 1 plus 1, alpha plus beta plus gamma, alpha square plus beta square plus gamma square, alpha plus beta plus gamma, alpha square plus beta square plus gamma square, alpha cube plus beta cube plus gamma cube. Yes. This is alpha to the power 4, beta to the power 4, gamma to the power 4, alpha cube plus beta cube plus gamma cube. This is alpha square, beta square plus gamma square, isn't it? If you see it very minutely, it is nothing but 111 alpha beta gamma alpha square beta square gamma square, and it is a multiplication of two things, two determinant. It is nothing but that thing, okay? And if you see both of them are same, so we can say that it is 111 alpha beta gamma alpha square beta square gamma square whole square. And if you see this, we have already done in previously. This is what? A minus b, b minus c, c minus a, which is alpha minus beta, beta minus gamma, gamma minus alpha whole square. This is it, okay? Let's proceed ahead. Now this question, you want me to solve this question. So let's try it. We'll break this in this addition. So we are going to get A1, I1 or L1, L1 only, L1, A2, L2, A3, L3. This is A1, L2, A2, L2, A3, L2 plus B1, M2, B2, M2, B3, M3, M2, A1, L3, B1, M3, A2, L2, 3, B2, M3, A3, L3, B3, M3 plus. Now we separated by this plus, isn't it? So it's a B1, M1, B2, M1, B3, M1, and if we consider these terms are going to be the same. So what will happen if we take, it is L1, L1, okay? If we take L1 common, this gone. If we take L1 common, this gone. If we take M1 common and we multiply A1 into L2, this will go. And if we multiply A1 into L3, this will go. And then we'll take M2 common. And we'll multiply B1, M1, M3. We'll minus it. It will become 0. So this is completely 0. This is completely 0. Similarly, we'll perform here. We are also going to get one of the rows 0. So overall, it's a 0. Okay. If you are facing problem, pause the video, again go behind and start watching. You will understand everything. Take this as a homework. Take this as a homework. Take this as a homework. Now we are on lecture 4. Okay. So lecture 4, cofactor matrix, adjoint matrix. So cofactor matrix and adjoint matrix. I am giving you 1 minute of break and then come back. Okay, 1 minute of break and then come back. So now we are available after the break. Cofactor matrices. Okay. So if we consider this is cofactor matrix. So cofactor matrix, if A is a matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33. So cofactor matrix is what? C11, C12, C13, C21, C22, C23, C31, C32, C33. So what will happen? C11 Cij is cofactor of Aij. This is it. Okay. So Cij, that means cof C is cofactor matrix of A. Okay. Got it? This is cofactor matrix. Okay. Second, adjoint matrix. Adjoint matrix. So adjoint of A is equal to C transpose. Adjoint of A is C transpose. Okay, that means what? Adjoint of A A is equal to C transpose matrix is what? C11, C12, C13, C21, C22, C23, C31, C32, C33. So this is cofactor matrix. Okay, this is adjoint matrices C transpose. That's all. Okay, that's all. So do you want to take any example, small example? Okay, then take it. If A is 1, 2, 3, 4, 5, 6, 7, 8, 9, find cofactor matrix and adjoint of A. So first, cofactor matrix C is equal to this one. The cofactor for this one is 945. 45 minus 48 minus 3. This one 36 minus 42 is minus 6, and this will become minus of minus 6, which is plus 6. If we go with this 32 minus 35, which is minus 3, 4, 18 minus 24, minus 6, 6. For this one 9 minus 21, minus 12. For this one, for 6, 8 minus 14, 8 minus 14, minus 6, 6, 7. For 7 we are finding the cofactor. 12 minus 15, minus 3. For 8 we are finding the cofactor. 6 minus 12, minus 6, which is 6. For 9 we are finding 5 minus 8, minus 3. Wow, this came out to be this. And adjoint A is C transpose, which is simply, okay, we should be noting that this is matrix. Okay, cofactor matrix, adjoint matrix. So C transpose is somewhere minus 3, 6, minus 3. I think they are the same. 6 minus 12, 6 minus 3, 6 minus 3. I think they came out to be the same. Okay, let's move ahead. Properties of adjoint matrix. We are on properties of adjoint matrix. So one, A adjoint A adjoint A is determinant of AIN. Okay, which is also adjoint A into A. So we'll prove this. We have A which is A11, A12, A13, A21, A22, A23, A31, A32, A33, and adjoint of A's cofactor 11, cofactor 12, cofactor 13, cofactor 21, cofactor 22, cofactor 23, cofactor 31, cofactor 32, cofactor 33. Now when we multiply A into adjoint A, what will happen? What will happen? We'll multiply A11 with C11, A12 with C12, A13 with C13. So if you remember, multiplying element with their cofactor and adding them will come out with the value of determinant. And if we multiply the element with other cofactor, it will come out to be 0. For this one 0. And now in this one will come out to be 0. This one is cofactor of this one, which is delta, determinant value. So 0, 0, 0, 0, 0 delta. If we take determinant value out, which is determinant A, this will become what? In. So can we say that A adjoint A is this thing? Okay, we got it. Now second property. Determinant of adjoint A. Determinant of adjoint A is equal to determinant of A to the power n minus 1. Okay, what will happen? We know that we know that A adjoint A is equal to determinant of AIN. Now we'll take determinant both the sides. This is determinant of determinant AIN. If you remember, this IN was going to be this IN. So this is what? If this is 3 into 3, it is 3 times, it is delta cube if you find the determinant. Similarly, if it is an IN time, it is determinant of A to the power n. And from this side we know that determinant of AB is determinant of A, determinant of B, which is equal to determinant of A to the power n. If you solve it further, we can say adjoint A is equal to determinant of A to the power n minus 1. So this is our proof. Okay. Do you want to proceed further with the third property? Third property is if A is symmetric, its adjoint is symmetric. Okay, if you see here, cofactor was symmetric, so adjoint was symmetric. That is the order. Okay, but you remember this property, good property. Fourth one, if A is singular, its adjoint is singular. That's all. We have to show that 3 into 3 is a skew-symmetric matrix. Then show that adjoint A is symmetric matrix. Adjoint is symmetric. Hmm, hmm, hmm. So what happened? We have to find that adjoint A will have to be symmetric. We know that A adjoint A is determinant of A in, and the value of determinant in skew symmetric is 0. Okay, okay. A is skew symmetric. Okay. So what can happen? We can take one example. We can take one example. Okay. A will be 0, 0, 0. A, B, C, minus A, minus B, minus C. We'll find adjoint of A. Simple. So adjoint of A is cofactor matrix transpose. So cofactor for 0 is what? C square. No, it's the minus C square, okay? Plus C square, okay? Minus C square, minus of minus C square. Cofactor of A will come out to be BC minus BC. Cofactor of B will come out to be AC. Cofactor of minus A will come out to be minus BC. Cofactor of 0 will come out to be B square. So I think it is A square. Cofactor of minus B is what? AC. Cofactor of C is what? AB. Plus minus plus minus minus AB. and this will be AB. So this is similar. This element same. This same. This is same. This will be minus AB. If it is AB, let's calculate for this one. It is minus AB. Okay. So it's a symmetric. So if it is symmetric, the transpose is also going to be symmetric. So that's all. Proved. Prove this. So this is a good proof. Let's have it. We know that A adjoint A is determinant of A in. Further, if we write adjoint in the place of A, it is adjoint A, adjoint of A, which is adjoint of A in. Yes. Further, adjoint of A is what? Determinant of A n minus 1 in. And we are getting here adjoint A. Adjoint A is what? Determinant of A in. And this is adjoint of A, which is further could be written as adjoint of A, which is equal to determinant of A to the power n minus 2. No, here adjoint A will multiply A both the sides. So A into adjoint A is this. Okay, got it. So this is this. You can remember this for further use. Second, from this topic you will definitely get one question in JEE Mains. So try to remember this. Okay. Second, now we have adjoint of adjoint. We have to find determinant of adjoint. Okay. So in place of A, we'll again put adjoint. So we are getting adjoint A, which is adjoint A to the power n minus 2 adjoint A. Yes. Now we'll multiply A both the sides. And we'll take determinant. Or let's wait for some time. Adjoint of A is what? Determinant of A to the power n minus 1 into n minus 2. And A into adjoint is determinant of A to the power n minus 1 in. Now we take determinant both the sides. We are getting determinant of A, determinant of adjoint of A is equal to determinant of A. If we take determinant of A n minus 1 common, this was determinant of A minus 1 whole square. And ION will add one more n. Okay. And when we take this side, it is going to be determinant of adjoint of A is equal to determinant of A n minus 1 whole square n into n minus 1. Okay. So this is the way it is coming. Okay. Let's move ahead. Inverse of a matrix. So hello crash course. So we are moving to inverse of a matrix. So what will happen if we come to inverse of a matrix? We know that A adjoint A is determinant of A in. So what will happen? What will happen is that A inverse is defined as adjoint of A upon determinant of A, which is equal to inverse of A. Okay, so determinant of A should not be equal to 0. This is how it is defined. Okay, okay. So next is, do we have property note? Okay, so we'll go with the property A. Determinant of A should not be equal to 0 for A to be inverse. Second, A inverse is always non singular. Okay. Third, if A is a diagonal matrix, A has only element in diagonal. This is 1 1, A 2 2, A 3 3, dot dot dot, A n n. Then A inverse will be having diagonal as A11 inverse, that is 1 by A11, 1 by A22, 1 by A33, dot dot dot, 1 by ANN. Okay, got it? Understood? Let's move with the third property. If we have A inverse, we have to find the transpose. We can simply detail it is A transpose inverse. Okay. Also, by this we can say that adjoint of A transpose is equal to adjoint A transpose. Okay. Fourth one, important point, A inverse is A. Determinant of A not equal to 0. Given. Fifth point, if we have to find K into A inverse, we can simply say it is 1 by K A inverse, where K is constant. Got it? This property we have already solved previously. Okay, if AB equal to AC, this implies B equal to C, then determinant of A is not equal to 0, because A should not be no, what A should not be singular. That is that if it is there, then we can tell that B is equal to C. Okay. Seventh, if A is symmetric, then A inverse is symmetric. 8. AB inverse could be written as B inverse A inverse. Determinant of B not equal to 0. Determinant of A not equal to 0. So we did everything. Now we are on the question, the side of question. We are told that we have A given, we have to find A adjoint A equal to determinant of AI. So I think we did the proof. Okay, if you go through this proof, we did that this is valid for every A. Okay, so that question is already solved. So we are going to move ahead. We are going to solve only at A inverse. So for A inverse, we are going to find adjoint A upon mod A. Okay, so adjoint A is cofactor matrix transpose upon mod A. So cofactor matrix is what? For 1, it is 16 minus 9, which is 7. For 3, it is 4 minus 3, 1, which is minus 1. 3, 3 minus 4, minus 1. For 1, 12 minus 9, 7, which is minus 7. For 4, 4 minus 3, which is 1, 4, 3, 3 minus 3, 0, 4, 1, 9 minus 12, minus 3, 4, 3, 3 minus 3, 0, 4, 4, it is 4 minus 3, 1. So what will happen? For A, what we'll do? We'll multiply 1 with 7, 3 with minus 1, 3 with minus 1. So we are going to get mod A equal to 7 into 1 minus 3 into 1 minus 3 into 1. It is going to be 1 only. Okay, so mod A is 1. And the transpose of this one is what? 7 minus 1 minus 1 minus 7 1 0 minus 3 0 1, which is going to be 7 minus 1 minus 1 minus 7 1 0 minus 3 0 1. So this is the A inverse. Show that the matrix A equal to 2 3 1 2 satisfies the equation this. Satisfies the equation this. So we'll have to do A square minus 4A plus I, and then we'll show that it is equal to 0. So let's continue. A square is A into A, which is 2 3 1 2 2 3 1 2, which is 2 2 ja 4, 4 plus 3 7, 2 3 ja 6, 6 6 12, 1 2 4 7. A square is this, minus 4A is minus 8 minus 12 minus 4 minus 8, and I is 1 0 0 1. If we do A square minus 4A plus I, it is going to be 7 12 4 7 plus minus 8 minus 12 minus 4 minus 8 plus 1 0 0 1, which is going to be 0 0 0 0, which is a capital O. This is what we did. Now we have to find A inverse. So what will happen? We have to find A inverse. So this is A square minus 4A plus I equal to 0. We'll multiply with A inverse. So A inverse A square is A, 4 into A inverse is I. This is A inverse. So can we say that A inverse is 4I minus A? Can we say that 4I is 4 0 0 4 and minus A is 2 3 1 2, which is equal to nothing but 2 minus 3 minus 1 2. So this is the answer. Let's move ahead. So that adjoint AB is equal to adjoint B adjoint A. So we have to show this, okay? We know that adjoint A adjoint A is determinant of A IN. In place of A, can we put AB? We can say it's adjoint AB. We can say this is determinant of AB IN. Further, we can say this is determinant of A, determinant of B IN. Yes. Now what will happen? Can we say that adjoint AB, and here we have A, B, and determinant of A could be written as uh, A inverse is adjoint A. If we multiply A inverse, if we multiply A inverse will be multiplied this side with determinant A and determinant B, In. This is adjoint A by, wait, wait. So what will happen? This is A, B. In place of A, we kept AB. So if we do A inverse A and B is here, and we have adjoint AB, so we'll have A inverse determinant of A, determinant of B, In. So here we'll get I. If you see, it is adjoint A by mod A. Yes. If you multiply AB, adjoint, we multiply A inverse, it will become adjoint A. Okay, wait. We'll take AV inverse. So it is adjoint AB, and this is what? AB inverse determinant of A, determinant of B, In. Can we say it is further B inverse determinant of B, A inverse determinant of A? Can we say B inverse determinant of B is adjoint B, and this is adjoint A? Hence, can we say that adjoint AB is this thing? Okay, let's move ahead. So I think we solved this one previously. So I will give you this as a homework. We solved this one already. Now we have to solve this one. Adjoint of A inverse. If we multiply A inverse, can we say it is determinant of A inverse In? Okay. So this is one equation. Second equation. A inverse A is In. Determinant of A inverse, determinant of A is 1. Determinant of A inverse is determinant of A inverse. Now if we substitute this, Put 2 in 1. Put 2 in 1. Can we say that A inverse adjoint A inverse is equal to determinant of A inverse? Okay. So A inverse could be written as adjoint of A upon mod A. If you go further, A inverse could be written as adjoint of A upon mod A, and this is adjoint of A inverse, which is 1 by determinant of A. If we go further, if you see A and A getting cancelled, so we are getting adjoint of A inverse is nothing but 1 by adjoint A. If you go further, can we say it is adjoint A to the power -1? We got the proof. Yes, sir. Let's move ahead. This solve it as a homework. Solve it as a homework. Solve it as a homework. Okay, I will take this question. Okay, I will take this question. We are given that A transpose is A, B transpose is minus B, A plus B is now singular, C is distinct. So C is given. So if we take C transpose first, it is what? A plus B inverse A minus B transpose. This could go like A minus B transpose A plus B inverse transpose. This could further go as A transpose minus B transpose, further as A transpose plus B transpose minus 1. A transpose is A, B transpose is minus B. So similarly this one will come out to be. So C transpose is this. Now we multiply C transpose with A plus B into C. A plus B into C, which is what? A plus B, A minus B inverse, and C is what? Uh, 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 uh. C transpose is this thing. C is AB inverse. C transpose AB inverse A minus B. So transpose, it became AB transpose, this transpose. This is A transpose B transpose, which is AB. This inverse will go up, B will come down. A transpose plus B transpose, A minus B. So this is correct. We are told it is A plus B. Okay, we are told it is A plus B, and then we have A plus B inverse A minus B. So this will become 1, and then this and this will become 1. We are overall left with A plus B. Got it? Second, C transpose A minus B into C. So C transpose is A plus B, A minus B inverse, and we have A minus B, and C is what? A plus B inverse A minus B. So this 2 will become 1, and then this one will become 1. We'll get A minus B. Let's move ahead. Now we are left with only 2 lectures. Okay. So we will have to solve this using elementary operations. So we'll try that. Okay, so we are left with only one lecture, I think. So we are left with only one lecture. Okay. Okay, so this is the last lecture. We'll try to complete it. Okay. Before this, we'll take 1 minute of some short break, and then we'll come back. Okay, let's come back. आज का लेक्चर कुछ 1 घंटे का बचा फिर मेरा तो भी है मेरा 6:30 का 6:30 नहीं 7:30 आज तो आज जो बोला जाए तो ओवर टाइम तो 1 घंटा मिला है तो ओवर टाइम से 2 घंटा मिला सर 1 घंटा मिला है ओवर टाइम तो 2 घंटे अब क्या 30 सेशन आ गया मेरा काम 30 सेशन अब इस सेशन में आपका ट्रैवल 30 सेशन अब इतना फ्लाइट पेंडिंग है मतलब इतना काम पेंडिंग है ये कर रहा हूं आप बस इस तरह हो आप इस तरह हो अभी So how many of you could solve this question? Tell me. So why do we perform elementary row transformation? If someone asks me why do we perform elementary transformation operation, now I wanted to say that if if matrix is singular, then finding inverse of it is not possible. Okay, so we use elementary row transformation to find inverse, to find their inverse. Got it? So now A is this thing, we have to find elementary operation. Okay, so what will happen? We have 0 1 3 1 2 1 2 3 1. We'll make R1 and R2 exchange, we will exchange it. So we'll get 1 2 3 0 1 2 3 1 1. Now what will happen? This is what we did. Now we'll do row 1 tending to row 1 minus row 2 minus row 3. Okay, so if you go from here, you are going to proceed somewhere like this. Row 1 minus of row 2 minus row 3. So this is minus 2, this is 0, this is 0. We are left with 0 1 2 3 1 1. Now what will happen? Can we divide one row with 2? So it is possible to make this arrangement. Let's see, is it possible to know or not? Okay, we'll make row 1 tending to row 1 by minus 2. So we'll get simply 1 0 0, and we'll do row 2. Okay, this is what we did. If we do row 3 tending to row 3 minus 3 times row 1, so it will become 0 1 1. This is 0 1 2 and more. And more, what can we do? We'll do in this row 3 tending to row 3 minus row 2. Okay, Okay, so we'll get somewhere 1 0 0 0 1 0 0 2 minus 1, and then we'll do what? uh, Row 3 tending to minus row 3, so it will become plus, and then we'll do row 2 tending to row 2 minus 2 times row 1, so we'll get what? 1 0 0 0 1 0 0 0 1. Yes. Now we did this one. Okay, we did this one. So now if you see, A is this thing, 0 1 2 1 2 3, 0 1 2 1 2 3, and 3 1 1 3 1 1, and we'll do something like 1 0 0 0 1 0 0 0 1, and we'll put A. Okay, now what we did, first step we did R1 R2 exchange. So first step we did R1 R2 exchange. So it was 1 2 3 0 1 2 3 1 1. Similarly here it will happen 0 1 0 1 0 0 0 0 1 A. Second step, what we did? We did R1 tending to R1 minus R2 minus R3. So R1 tending to R1 minus R2 minus R3, which is minus 2 0 0, and this was 0 1 2 3 1 1. So similarly we'll do, it will become minus 1 1 minus 1 1 0 0 0 0 1. Next we are doing R1 by minus 2. So R1 by minus 2. So 1 0 0 0 1 2 3 1 1 3 1 1. Okay, and it is 1 by 2 minus 1 by 2 1 by 2 1 0 0 0 0 1 A. Now R3 tending to R3 minus 3R1. So R3 tending to R3 minus 3R1, which is 0 1 1 1 0 0 0 1 2. R3 tending to R3 minus 3R1. 3R1 is minus 3 by 2, 3 by 2, minus 1 by 2, and this is A. This is 1 by 2, minus 1 by 2, 1 by 2, 1 0 0. Okay, after this step is R3 minus R2. So R3 minus R2, which is 0 0 minus 1 1 0 0 0 1 2. So R3 minus R1 is minus 1 by 2 only, 3 by 2 only, minus 5 by 2. This is 1 0 0 1 by 2 minus 1 by 2 plus 1 by 2, and this is A. And then last one is R3 is minus R3. R3 is minus R3, and then R2 is R2 minus 2R1. R2 is R2 minus 2R3. R2 is R2 minus 2R3, which is 1 0 0 0 1 0 0 0 1. R2 is R2 minus 2 R3. So this is 5 by 2 minus 3 by 2 1 by 2 A. R2 minus 3R by 2, which is minus 3 by 2. It is 9 by 2. It is minus 15 by 2. And this is 1 by 2 minus 1 by 2 1 by 2. Okay. So we can say that this is A inverse and this is A. So A inverse is what? 1 by 2 minus 15 by 2, 5 by 2 minus 1 by 2, 9 by 2 minus 3 by 2, 1 by 2 minus 3 by 2, 1 by 2. So this is it. Okay. So this is the way we find the inverse. Let's move ahead. Now we are on Cramer's rule. Okay. So I think most of you might be knowing what is the Cramer's rule. Okay. So most of you might be knowing what is Cramer's rule. Do you all know or not? Cramer's rule is finding delta x, delta y, delta z like that. Do you all know or not? So I will be carrying that, okay? So what will happen? Okay. We are given a equation, okay? We are given equation as a1x b1y equal to c, a2x c1, okay? b2y equal to c2, okay? So what will happen? We'll find determinant, which is a1, a2, b1, b2. We'll find as delta x. So in place of a1, a2, we'll put c1, c2. Okay. Now we'll go with delta y. So in place of b1, b2, now in this determinant, in place of b1, b2, we'll put c1, c2. So this is a1, a2, c1, c2. Now if I tell you to find the value of x, x is nothing but delta x by delta, which is what? b2 c1 minus b1 c2 upon a1 b2 minus b1 a2. If we find y, y is what? Delta y by delta. Delta y is what? A1 C2 minus C1 A2, and determinant value is what? A1 B2 minus B1 A2. Okay, so this is the way we have to find the value of x and y. Now if we are given three variable equation, this is two variables. If we are given three variables, so this is two variable. Now if we go with three variable, okay, so we will be having a1x, b1y, c1z equal to d1, a2x, b2y, c2z equal to d2, a3x, b3y plus c3 equal to c3z equal to d3. Now what will happen? We'll find first delta. Delta is what? A1, A2, A3, determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. Delta X will come out to be, in place of A1, A2, A3, we'll put D1, D2, D3. C1, C2, C3. Delta Y. Delta Y. So what will happen? We'll put this determinant in place of Y. We'll put D1, D2, D3. So this is A1, A2, A3, D1, D2, D3, C1, C2, C3. Now we have delta Z. So in place of Z, in this determinant, in place of C1, C2, C3, we'll put D1, D2, D3. So A1, A2, A3, B1, B2, B3, D1, D2, D3. Now X is what? Delta X by delta Y is delta Y by delta Z is delta Z by delta. I think you got it. You got it. Okay, you got this one. Let's move ahead. So we have few criteria: consistent and indeterminate. Okay, so for consistent and determinant, delta should not be equal to 0. Okay, second, for indeterminate, delta is equal to 0. Okay, So for inconsistent, delta equal to 0, okay, in determinant form, okay, delta equal to 0 and delta x, delta y, delta z equal to 0, okay. Inconsistent, inconsistent, delta equal to 0 and any of delta x, delta y and delta z is not equal to 0, then it will be indeterminate. Inconsistent, indeterminate meaning infinite numbers of solution. Consistent and determinate meaning unique solution, okay. For unique solution, for unique solution, delta not equal to 0 will get unique solution. If you want rank wise, so rank of A D is equal to rank of A equal to order of matrix. For this one, indeterminate, rank of, this is out of the syllabus but I am telling in case if it is asked in any of the question, rank of AD is equal to rank of uh, rank of A and which is less than order of matrix, okay. For inconsistent, rank of AD is more than rank of A, okay. Now we got some question like this, okay. Find the real values of lambda and mu so that the following system has this and that. So first tuple, we'll write this in the form of determinant 1 1 1 1 2 2 1 3 lambda, delta x, in place of x we have 6 1 mu 1 2 2 1 3 lambda, delta y 1 1 1, in place of 1 6 1 mu, and this is 1 3 lambda, delta z 1 1 1 1 2 2 6 1 mu. Let's find delta. Delta value is If we minus what? Column 1 with 2 times of column 1, which is 1 1 1. This is 0 0. This is minus 1 0 0 1 3 lambda. If we open it by column 2, we are going to get lambda minus 3. So for unique solution, okay, let's find it. And delta x we are finding now. Okay, so delta x is going to be 6, 2 lambda minus 6 minus 1 lambda minus 3 mu plus 1 2 minus 2 mu, which is 12 lambda minus 36 minus lambda plus 3 mu plus 2 minus 2 mu, which is 11 lambda plus mu minus 34. Delta y is 1 lambda minus 3 mu minus 1 6 lambda minus mu plus 1 18 minus 1 17, which is lambda minus 3 mu minus 6 lambda plus mu plus 17, which is nothing but minus 5 lambda minus 2 mu plus 17, and we'll find finally delta z, which is 2 mu minus 2 minus 1 mu minus 12 plus 1 1 minus 12 is minus 11, which is 2 mu 12 minus 11 1. Okay, this is what. Now if we go with 1 unique solution, that means delta not equal to 0, that means lambda not equal to 3. Second, infinite mini solution, that means delta equal to 0 and upper part is also 0, mu equal to 1, mu equal to 1. So at mu equal to 1, lambda equal to 3. So we are going to have delta x 0, delta y is what? 15 minus 2 7. Delta y is 0, delta z is 0. So this is the solution. So third, no solution, that means lambda equal to 3 but mu is not equal to 1. Okay, so this is the solution, and see, we are getting the exact answer, that means our concept is correct. Let's move ahead. So we can find this value using Cramer's rule. So let's apply Cramer's rule. Delta is coming out to be 2 5 7 1 minus 6 4 6 4 minus 3. Delta x is in place of x will put 46 15 19, 1 minus 6, 4, 6, 4 minus 3. Delta y is, we have 2, 5, 7. In place of this we'll put 46, 15, 19, 6, 4 minus 3. Delta z is 2, 5, 7, 1 minus 6, 4. In place of this 46, 15, 19. Now what will happen? X is simply delta x by x, delta x by delta. Y is simply delta y by delta. Z is simply delta z by delta. Solve it and put it here. You will get the answer. I just gave you the complete hint because we have already solved this question previously. Here. Okay. In this question, people are facing problem. So what will happen? We'll put capital X equal to 1 upon x plus 5 and capital Y equal to 1 upon y plus 7. So we have simply 4 capital X, 3 capital Y equal to minus 1, and we have 6 capital X minus, this is minus, 6 capital Y equal to minus 5. So delta will come out to be 4, 6, 3 minus 6. Delta x will come out to be, in place of x we'll put minus 1, minus 5, 3 minus 6. Delta y, in place we'll have this thing, in place of y we'll put minus 1, minus 5. So 4, 6 minus 1 minus 5. So for this if we calculate, it's simply minus 20 plus 6 minus 14. If we solve it, minus 24 minus 20 minus 18, which is minus 42. And if you solve this, it is 6 plus 15, 21. So x is nothing but, capital X is nothing but delta capital X by delta, which is 21 by 42 equal to 1 by 2. Capital Y is nothing but delta capital Y by delta. So delta capital Y is what? Minus 14 by minus 42. It's a minus 42. So it's a minus 1 by 2. This is 1 by 3. Now capital X is what? 1 upon x plus 5 equal to minus 1 by 2. So we can solve simply x equal to minus 7. Similarly, 1 upon y plus 7 is equal to 1 by 3. So y equal to minus 4. So this is it, and this is it. Okay. Now we have to solve this one. So what will happen? Here x square will be considered as capital X, y square as capital Y, z square as capital Z. Solve it. You will find, I think you are going to find delta equal to 0, delta x equal to 0, delta y equal to 0, delta z equal to 0. Solve this. Okay. Homogeneous equation. Homogeneous system of equation. So what will happen in homogeneous equation? If we have an equation like a1x, b1y, c1z plus dot 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 equal to, it was d1, yes, a2x, b2y, c2z. This is not, it is three variable on it, d2, a3x, b3y, c3z is equal to d3. Then 4 homogeneous equation, d1 equal to d2 equal to d3 equal to 0. So this side will always have to be 0. Okay. So what will happen if it is 0? Then you see that delta is determinant calculated from this side. So delta may or may not be 0. Yes. One. Second, delta x. So delta x, what happened? We calculate delta and in place of x we put 0 0 0. So delta x, delta y, delta z is always equal to 0. Okay. So what will happen? What will happen? See. So this is the case. So we have two case. Two case is that this is the first case when delta is not 0. Then delta x, delta y, delta z is 0. That means the solution is always 0. Solution is always 0. Then we should tell it as a trivial trivial solution. Okay. Now for second point, if delta is equal to 0 and we know that delta x equal to delta y equal to delta z is 0. So can we say infinite solution? And now if it is infinite solution, so solution could be anything other than 0 comma 0 comma 0. Hence non trivial solution. Got it? Got the logic? So this is the question, so that the homogeneous equation have a non-zero solution. Okay. So to solve this, first we'll take lambda x, lambda y, lambda z this side. So can we say it is 1 minus lambda x plus 2y plus 3z equal to 0, 3x plus 1 minus lambda y plus 2z equal to 0, 2x plus 3y plus 1 minus lambda z equal to 0. Now we know that delta x, delta y, delta z is going to be 0. So our aim is to calculate delta. So it has non-zero solution, meaning infinite solution. That means we have to make delta equal to 0. So let's find delta. It is 1 minus lambda, 2, 3, 3, 1 minus lambda, 2, 2, 3, 1 minus lambda. So let's solve it. It is 1 minus lambda upon the determinant. 1 minus lambda whole square minus 6 minus 2, 3 minus 3 lambda minus 4 plus 3, 9 minus 2 plus 2 lambda equal to 0. If you solve it, it is simply 1 minus lambda whole cube minus 6, 1 minus lambda, and here if you get, it is minus 1 plus 2 plus 6 lambda, and here we have 21 plus 6 lambda. This is 1 minus lambda cube minus 3 lambda plus 3 lambda square minus 6 plus 6 lambda plus 23 plus 12 lambda equal to 0. Further solving will take everything that side. So lambda cube minus 3 lambda square, 18 minus 3, 15, going that side minus 15 lambda. We have 17 plus 1, 18. If you take that side minus 18. Okay, so finding this has become a bit difficult. Okay, finding this has become difficult. 1, 2, 3, 4, 5, 6, so it is somewhere going out to be 3 lambda square minus 6 lambda minus 15 equal to 0. So lambda square minus 2 lambda minus 5 equal to 0. So what can happen? We can find the lambda value for which it is 0. I think we may be having some calculation error. From there, if you find the value of lambda, for those value of lambda, this is going to be infinite solution, hence non-zero solution. So similarly, this is homogeneous equation. So we have to find delta equal to 0. And we have complete equation is lambda and cos alpha. So based on the value of lambda cos alpha, find it. Homework. Delta equal to 0. Solve it. Delta equal to 0, this question. Homework. Okay. So characteristic Hamilton theorem. This theorem is told that characteristic Hamilton theorem, what does it says? Okay. It is saying that if we have a matrix A, okay, if we have a matrix A, if we have a matrix A, then there there exists a matrix lambda I such that determinant of A minus lambda I is equal to 0. Okay, okay, so this is what it says. So if A is 1 0 1 2 1 0 3 2 1, then there will exist some lambda. So for example, if we take A minus lambda I determinant equal to 0 and we are trying to find what is that lambda, so can we say that it is 1 0 1 2 1 0 3 2 1 minus lambda I is lambda 0 0 0 lambda 0 0 0 lambda, and we'll find determinant of this equal to 0. Okay, so when we'll solve this, okay, we are going to get 1 minus lambda 0 0 2 1 minus lambda 0 3 2 1 minus lambda. So we are trying to solve this. We'll expand by this one. This is the determinant. We'll put it 0. Okay, in order to make it simpler solving, okay, we'll make it 0. So it is simply 1 minus lambda whole square. Okay, it is equal to 0. So lambda equal to 1. So this is the lambda for which this is correct. Okay, this is what it is saying. So if we move to this question, we are told that a non-scalar is satisfying this thing, then prove that characteristic equation of matrix A is this. So we'll have a matrix A equal to maybe it's a square. So A, B, C, D. So we are doing what? We are doing A minus lambda I equal to 0. So this is nothing but determinant of A minus lambda B C D minus lambda equal to 0. When we solve it, it is AD A lambda minus D lambda plus lambda square minus BC equal to 0. So if you see, it is lambda square minus lambda A plus D plus AD minus BC equal to 0. So what happened is that this lambda is there is some lambda existing for A. So what happened if we consider this? If we consider this, it is what? X square minus, if we consider minus A plus minus of A plus D, if we consider this as L, can we say Lx and this as M equal to 0? And can we say it is same for A square La plus M equal to 0? So this will be correct for both of them. Okay, now this is the equation. We have to find the value of x cube. So what will happen? We have A minus lambda I determinant equal to 0. So we'll go 1 minus lambda 0 2 0 2 minus lambda 1 2 0 3 minus lambda. We'll put it equal to 0. Let's solve it. 1 minus lambda 2 minus lambda 3 minus lambda plus 2 lambda minus 2 into 2 equal to 0. Okay, it is 4 lambda minus 8. If you solve it, it's a lambda square minus 5 lambda plus 6, and this is minus of lambda minus 1. This is equal to 0. This is minus lambda cube minus 5 lambda square plus 6 lambda minus lambda square plus 5 lambda minus 6 plus 4 lambda minus 8 equal to 0. If you solve it further, you are going to get lambda cube, so it's minus 6 lambda square 11 plus 7 lambda, which is minus 6 plus 6 minus 8 minus 2 plus 2. So if you compare this equation with this one, can we say k is equal to 2? So this is the way Hamilton equation is helping us to solve this question. Okay, in this question, I think we solved this question. Okay, ABCD. ABCD we took it, yes. If you see, this is what? Lambda square minus lambda A plus D plus AD minus BC. Okay, and we are given that this is x square plus k equal to 0, and we are getting somewhere x square minus x a plus d plus ad minus bc equal to 0. Can we, after comparing, can we say that k is equal to ad minus bc and a plus d equal to 0? So which is also equal to determinant of a. So I think if you go with option A, it is correct. Option A is correct. So I think we are done with the topic. So basically